Hello, students. Welcome all on to your journey to that perfect A star in your AS and A level exams of Cambridge Mathematics. I am Pankaj, your maths mentor, and together we are going to walk that journey. Students, in this session, we're going to start solving AL Pure Math 3 question paper. It is from the Feb-Mar series. The year is 2022, and the question paper code is 32. So, let's begin the day. Let me share my screen. So the very first thing that we should always take care of is to go through the instructions which are given on the very first page of the question paper. The most important instructions are, as I've always tell, these ones. First of all, you should show all necessary working very clearly. No marks will be awarded for any unsupported answers from a calculator. So students, steps are the most important thing while you are writing the solutions for a particular question. And the second one is, when there is an non-exact numerical answers, then you should be writing those answers up to 3 significant figures or 1 decimal place for angles in degrees, unless a different level of accuracy is specified in the question. So unless and until there is any particular specifications given in the question, you should always maintain what instructions are given to you. So the instructions are very clear. You should be using 3 significant figures for any non-exact numerical answer. That means if your answer is not an integer, then you should write 3 significant figures. And if it's an angle, then you should write the angle up to 1 decimal place, and the angle should be in degrees. If it is in radians, then of course you'll be following the first instruction of writing the answer up to 3 significant figures. So these are the 2 most important instructions you should always keep in mind. I always tell my students to read the instructions. The other instructions are the general instructions. This question paper is for 75 marks, and the time allotted is 1 hour and 50 minutes. So students, without much ado, let's begin the very first question. So you can see the first question is, solve the inequality. The inequality is modulus of 2x plus 3 greater than 3 times of x plus 2. Now, there are 2 different methods to solve this particular question, but I usually rely on the first method, and I recommend my students also to do the first method. In the second method, students, we are going to do squaring. We are going to get a quadratic equation. We are going to solve that quadratic equation, and then we solve for the value of x. But believe me, it is a lengthy process. The first method is the most convenient method, and it's an easy method as well. The question paper is for 1 hour and 50 minutes. So you should be smart in managing your time. So the first question, that's for 4 marks. Let's begin with the question. So it says, solve the inequality modulus of 2x plus 3 is greater than 3 times of x plus 2. So how do I begin? The first thing that you should be doing is transforming this inequation into an equation. So things become slightly easier if you work with an equation. So what I'm going to do here is I'm going to write the inequation. I'm going to transform the inequation into an equation. So I get modulus of 2x plus 3 is equal to 3 times of modulus of x plus 2. Now, we all know what a modulus function is, right? So if I have modulus of x equal to a particular value, if modulus of x is equal to some certain value, let's say k, then x will become equal to plus and minus k. We should impart a positive and a negative sign on any one of the sides of the equation. So what I'm going to do here as well is I'm going to remove the modulus sign, and I should be imparting a positive and a negative sign on any one of the sides of the equation. So I write it like this. I write 2x plus 3 is equal to plus and minus 3 times of x plus 2. So now you are going to get 2 linear equations, and we're going to solve them for the value of x. So I write 2x plus 3 is equal to positive 3 times x plus 2, or you can write 2x plus 3 is equal to negative of 3 and it multiplies with x plus 2. Now let's simplify both of them. So I get here 2x plus 3 is equal to 3x plus 6. Let's collect all the like terms together. That means all the terms of x will come together, all the constants will come together. So I'll be shifting the 2x on the other side and the 6 on the left side. Okay, so what do I get now? So I can go further and write 3 minus 6 is equal to 3x minus 2x. So that gives me x equal to negative 3. So that's one of the value of x that I've got. X is minus 3. Now let's simplify the other equation as well. So there I have 2x plus 3 is equal to minus 3x and minus 6. So again, what I'm going to do, I'm going to collect all the like terms together. That means all the terms of x will come together and all the constants will come together. So I get 2x plus 3x is equal to minus 3 and minus 6. So that gives me 5x is equal to minus 9. So x comes out to be minus 9 upon 5. Or you can say negative, so that's 9 upon 5. So 5 times 1, that's 5. And then 4 is left. So you will put a decimal sign. That becomes 40. It gives you 8. So minus 1.8. So that's the value of x, another value of x. Okay. So I have got two different values of x. Now the things are very interesting from here. Just pay proper attention. So what I'm going to do here is I'm going to first of all draw a number line. See, you want to find a range. It's not an equation. It's an inequation. So you want to find the range of x. So I'll first draw a number line. Let's draw a number line. And let's mark the values. Let's say this particular point is x equal to minus 3. So from the two values, you can definitely understand that minus 3 will come first and then minus 1.8 is going to come, right? So if you start from 0, so 0, then negative 1, negative 2, negative 3, and so on, the values will keep on coming. So you are going to first encounter, so if you are starting from 0 and moving towards the left, then what will happen? So if you're starting from 0 and moving towards the left, then you get 0, negative 1, negative 2, negative 3, and so on. So I get minus 3, and then I have the value of x as minus 1.8. Okay, so you start from 0 and you are moving towards the left direction. Okay, so 0, negative 1, negative 2, negative 3, and so on. So I have the two values of x. X is negative 3, x is negative 1.8. So there are now two different regions. Basically, there are three different regions, but you should be considering two regions. Now, what are these two regions? Try and understand this. So the first region is over here in between negative 3 and negative 1.8. That's the first region, students. This is the first region. This is the region where x lies between negative 3 and negative 1.8, right? There are infinite number of values between negative 3 and negative 1.8. The next region is ahead of this over here. Okay, this is the region where x is greater than negative 1.8 and behind x equal to minus 3. Over here, x is less than minus 3. So as I said, there are total two regions, but they look like there are three regions. So there is one region which is the red colored region, and then there is one region which is the orange colored region. So the orange colored region seems to be separated, but actually it is not. Okay, so they are both one and the same regions. So now what you should be doing is you should be picking a value from the particular regions. Okay, so let's take a value which is more than negative 1.8. Let's take one value from the orange colored region. X is greater than minus 1.8. So can you think of some value which is greater than minus 1.8? So it's very simple to understand. It can be negative 1, it can be 0, right? So over here, you can have values of x like -1 or 0 or 1 or 2, 3, and so on. So you can pick any value that you want. So maybe I'll take the simplest value. The simplest value is 0. So I take this 0 and I go to my inequation. Students, go to the inequation, and in this inequation, you plug the value of x as 0. So I'm going to plug x equal to 0. So if you plug x as 0, what will happen? So you get 2 times of x is 0 plus 3, right? Modulus greater than 3 times of x is 0 plus 2. So what would happen? So it's 2 times of 0, which is 0, 0 plus 3, that's 3. Modulus of 3 is 3. So I'm working on the left-hand side of the inequation, right? So I've got the answer as 3. Greater than, the right-hand side is 0 plus 2 inside the modulus sign. So 0 plus 2 gives you 2, multiplies with 3, that gives you 6, right? Modulus of 2 is just 2. So it multiplies with 3, you get 6. Is 3 greater than 6? Is 3 greater than 6? Students, ask the question to yourself. Is 3 greater than 6? The answer is no. 3 is not greater than 6. That means x equal to 0 has not satisfied the inequation. So x equal to 0 is not your solution. That means any value which is lying ahead of -1.8 does not belong to the solution. It's not the part of the solution. Same way you can check for any value which is beyond -3. For instance, you can take -4. Okay, so here you can have some value as -4, -5, and so on. Okay, so if you take a value, say -4, let's take a simpler value. So I'm going to take -4. So I'm going to plug the value of x as -4 now. So these steps are not needed in the solution. Okay, this should work in the background. They should work in your mind. You don't have to show them into your solution. So x, I'm going to plug the value of x as, say, -4. So what do I get? If I plug the value of x as -4, I get 2 times of -4 plus 3 inside the modulus sign greater than 3 times of -4 plus 2. So that's 2 times of -4. 2 times of -4 is -8. -8 plus 3. -8 plus 3 is going to be -5. Modulus of -5 is 5. Greater than. Inside the modulus sign, you have -4 plus 2. -4 plus 2 is going to come -2. Modulus of -2 is going to be 2. 3 times of 2 is 6. Is 5 greater than 6? Students, the answer is again no. That means x equal to -3 is also not the solution, right? So x equal to not -3, x equal to -4. Values which are beyond -3 also do not belong to the solution set. Now, if you want, so this from the very first value itself, you have identified that the orange colored region is not the solution set, students, isn't it? You don't have to keep on doing for every single value that is present over there. Just pick one region, either the red colored region or the orange colored region. And from the orange colored region also, you just want to pick any one of the side. You don't have to pick both the sides. Just pick one side, take a value from there, put it in your inequation. If your inequation gets satisfied, you will say that the orange colored region is your solution set. You can check for the red colored region as well for not the solution. Okay. And if the orange colored region is not satisfying the inequation, then definitely the red colored region is going to satisfy. You can check also. So can you pick a value which is lying between -3 and -1.8? So maybe you can pick value of x as, let's say, you can pick the value of x as -2, right? -2. So let's plug the value of x as -2 into your inequation. So let's try and do this. Okay. So again, I'm telling students, these steps are not needed to be shown into your solution. They are only there for understanding. So if I plug x as -2, -2, what do I get? So that's 2 times of -2 plus 3 inside the modulus sign greater than 3 times of -2 plus 2. So what do I get? So 2 times of -2. 2 times of -2 is -4. -4 and plus 3. -4 and plus 3, that gives me -1. A modulus of -1 is 1. In the right hand side, what you're going to get? So greater than -2 plus 2, that's 0. Modulus of 0, it's going to be 0. 3 multiplies with 0. The answer is 0. Is 1 greater than 0? The answer is yes. That means I can definitely say that the red colored region is your solution set. Any value which lies in the red colored region. So the red colored region is the region which is starting from -3 and ending at -1.8, isn't it? So this is that region, students. Okay, in this region, you can take any value that you want and you will find that the value is definitely going to satisfy your inequation. So that's your answer. Very simple. So therefore I can say x lies from -3 to -1.8, and you can just highlight the answer. Okay, so that's the first method of getting the solution. The second method, as I said, will involve first of all squaring the inequation. There you don't have to transform it into an equation. You can just maintain an inequation. You can do squaring both the sides. You can simplify it for a quadratic equation. Then you will be getting two different values of x. Now this method I have explained in one of my previous question papers. You can definitely go and visit that video as well to understand the method if you want. I'll give the link down below into the description box for that particular video. So that was all about first question, and see, very easily you have scored the first 4 marks of the question paper, isn't it? So now it's time for us to move to the second question. So students, in the second question, now what do we have? It says that on a sketch of an Argand diagram, shade the region whose points represent complex numbers z, satisfying the inequalities modulus of z plus 2 minus 3i is less than or equal to 2, and argument of z is less than or equal to 3 upon 4 pi. Now, students, you definitely must have learned your complex numbers chapter very thoroughly. It's a very important chapter, students. You need to know your basic concepts very thoroughly. So, even if there is some confusion into that particular chapter, just know one thing. The first inequation that is given to you, the modulus of z plus 2 minus 3i less than or equal to 2. So, the first inequation is going to represent a circle. This always remains the same. Okay, so if you have anything that is given inside a modulus, so z plus a, z minus a, okay, so a is a complex number here, okay, constant complex number. So the first inequation is always a circle. And the second thing that is written over here, argument of z less than or equal to 3 upon 4 pi, this is going to be a line. This is going to be a line. That is what we need to draw over here. So you're going to get a circle, you're going to get a line, and you want to find the common region which will be satisfying both of these inequations. See, both of them are the inequalities. In the previous question, if you observe, there was less than sign or greater than sign. Not the less than, greater than sign, right? There was not a greater than or equal to sign. And that's why my answer also does not contain the equal to sign. Did you notice that? There is no equal to sign in my answer because the question did not contain the equal to sign. The inequation has a greater than sign. It was not a greater than or equal to sign. So these few things you need to always take very proper care of, the signs, the inequalities, the equalities. Okay, but in this particular equation, in the second question, the inequation that is given to us, in that inequation you can see the equality sign as well, right? So the equality sign means that the points which are lying on the curve will also become the part of the solution set. What did I say? I said that the points which lie on the curve. So the first curve is a circle, the second curve is a line. Okay, so the points which belong to the curve will also become the part of the solution set. That is what that equal to sign means. Okay, so I'm going to start solving the second question. The first inequation that you have is modulus of z plus 2 minus 3i is less than or equal to 2. Now, I know this is going to be a circle. I know the center's coordinates are going to be -2 and +3, but that's just a direct implication. the question paper had a clear instruction that you should be showing all the necessary working. So please write your steps. So look at the steps, what the steps are going to be looking like. So I have modulus of z plus 2 minus 3i less than or equal to 2. Now we know that z is always given as x plus iy, right? Z is always x plus iy. So I get modulus of z, which is x plus iy, plus 2 minus 3i less than or equal to 2. That gives me modulus of x plus 2 plus I times of y minus 3 less than or equal to 2. Is that right? So now I can go further. So when you say modulus, can you see this part is the real part and this part is the imaginary part. So when you are going to write modulus of x plus I y, x is the real part, y is the imaginary part. Don't you write it like square root of x square plus y square? So that's square root of the real part square plus the imaginary part square. So in our case, it's going to be what? Square root of x plus 2 the whole square plus y minus 3 the whole square is less than or equal to 2. So what you now need to do is just squaring. So if I do squaring both the sides, I'll be simply getting x plus 2 the whole square plus y minus 3 the whole square is less than or equal to. So you are going to do squaring on both the sides, okay? Is less than or equal to 4. So can you now identify that this is the equation of a circle in the center radius form, right? So this is the center radius form of equation of circle. So I can write center radius form of equation of circle. Is that right? And what is center radius form, students? Do you recall it? Is it x minus h the whole square plus y minus k the whole square is equal to r square, where h and k are the x and the y coordinates of the center, and of course r is the radius. So what's the center in our case? So center is going to be x minus h. You have x plus 2. So x plus 2, x minus h. So the value of h is going to be how much? It's going to be minus 2. And y minus k, y minus 3. So k is going to be 3. So center is negative 2 comma 3. And what's the radius going to be? So radius, so it is equal to r square. So r square is 4. That means r is going to be 2. So radius r is going to be 2. So you have got the radius of the circle as 2 and the center of the circle as negative 2 comma 3. So now you can clearly make a circle, right? You can just draw a circle. So you can see you want the center as negative 2 comma 3, right? So you have to take x as negative. So what I'm going to do here is, and y is 3. So y can be taken positive. So I'm going to draw the x-axis over here. Okay, let's draw an x-axis. So I'm going to take the second quadrant, students. I'm going to take the second quadrant because I know that the value of x is negative, right? The value of x is negative. So I should be drawing the diagram like this. So there is x-axis and then there is y-axis. I'm going to take some points. So maybe this point can be taken as -1. This point is -2, then I can have a -3 and so on. I can keep on going further, right? Then I can have this 1, 2, and 3. So what is told about the center? Where does the center lie? Center is -2 comma 3. So x is -2 and y is 3. So I can clearly understand that this is going to come over here. So that's this point that I'm going to draw is -2 and 3. Right, students? So that's -2 comma 3. So I have my center here. This is the center of the circle. right? It's negative 2 comma 3. Now you know that this circle has radius how much? The radius is 2. So can you say from this point to P is the length? So length of CP, is it 2? Length of CP, is it 2? That means CP is your radius, right? So you want to draw a circle. You want to draw a circle such that its radius is 2 and the center is at negative 2 comma 3. So I'm going to draw a circle like this. Let's draw a circle like this. Okay, so I have drawn a circle and I'm going to place it in such a way that the center should look at negative 2 comma 3. So let's make a appropriate diagram, students. So appropriate diagrams are very necessary. Okay, so you can definitely make use of a scale, pencil, rounder, right? Whatever you have. Okay, so it's going to look like this, right? So that's your circle having its center at negative 2 comma 3 and the radius is 2. So of course it will be in such a way. Now of course my diagram, I do not have scale over here, so it's going to be tangent to this particular line as well. Okay, so I'm not going to keep that line over there. So this is how the diagram for circle needs to be made. So first diagram is done, students. Now we are going to start with the second inequation. The second inequation was argument of z is less than or equal to 3 upon 4 pi or 3 pi by 4, you can say. So I'm going to write over here argument of z is less than or equal to 3 pi by 4. Right, students? Argument of z is less than or equal to 3 pi by 4. Now, don't you know what is argument of z? It's simply going to be tan inverse of the imaginary part upon the real part. So it's tan inverse of y over x, isn't it? So I'm going to write over here argument of z is tan inverse of y upon x less than or equal to 3 pi upon 4. That should give me y upon x is less than or equal to tan of 3 pi by 4. So 3 pi by 4 is 135 degrees. It's in the second quadrant. Second quadrant tan is negative. So you should be aware of this value, straightforward. So tan of 3 pi by 4 is -1. If not, go to the calculator, use the radian mode to get the value of tan of 3 pi by 4. So the calculator is also going to show the answer as -1. So I get y upon x less than or equal to -1, or I say y is less than or equal to -x. That's your inequation. That's your second inequation. So I had my first inequation over here, isn't it? That was a circle. And the second inequation, you can observe, does it not look like y is equal to -x if you make use of an equation? Y equal to -x, that's the equation of a line. It's a linear equation. So I'm going to draw the graph of y equal to -x. So you can again clearly understand that the line y equal to -x is a line which is passing through origin, isn't it? It's a line which is passing through origin. So I'm going to draw a line which is going to pass through origin, and it will definitely pass through the point -1, 1, x is negative, right? X negative, -1, and y will be positive 1, or it can be -2, 2, isn't it? So I'm going to draw a line which is going to pass through these points. Okay, so let's draw a line which is going to pass through the origin, and it is also going to pass through the points -2, 2, -1, 1, and so on. So as I said, an appropriate diagram is sufficient to make you understand what's happening over there. Okay, so this line that I've drawn, this line is the line whose equation is y equal to -x. Okay, but I want to find all those points, all those values of z which will be satisfying both the inequations and not the equations, right? Inequations. So students, you need to pick one point. Let's take one point, maybe this point. Is it -1, 0? That's -1, 0, and plug it into this equation, -1, 0. So in place of x, you are going to plug -1, and in place of y, you're going to plug 0. So that's 0 less than or equal to minus of -1. What's happening? 0 less than or equal to 1. Is that true? Is 0 less than 1? The answer is yes. That means this point, -1, 0, this point that I've marked over here, this point is definitely a point which belongs to the solution of y less than or equal to -x. So there are two different regions that you can have. So the line is passing through origin. So there is one region which is below the line, which contains the x-axis, the negative region, the negative part of the x-axis, and one part is above the x-axis, not above the x-axis, sorry, is above the line. So above the line, you contain the positive direction of the y-axis. So you should be taking 1 point from the x-axis, 1 point from the y-axis, put it in the equation, and see which point is satisfying. Whichever point satisfies, that part becomes the solution set. Okay, that part is the region. Okay, and same is with the circle. So for the circle, you have the less than or equal to sign again. Okay, x plus 2 the whole square plus y minus 3 the whole square less than or equal to 4. So again, if you take any point which is lying inside the circle, it will definitely satisfy the inequation. So I have this region as the solution set for the equation of a circle, right? The area which is present inside the circle becomes the solution set for the inequation of the circle. And then I had the line which was passing like this, and for this line I had the region which is below, right? Below the line, the region below the line was satisfying the inequation of the line. So now if you see, the common region is definitely that region which is below the line and inside the circle. So I'm going to shade that region, students. I'm going to shade that region. Let's quickly shade the region. Okay, so isn't this the region which will satisfy both the inequation? So this is the region which will be satisfying both the inequations simultaneously. So this becomes your solution. Okay, that is what the question is, right? You want to find what? You want to find the solution set. You want to find the values of x. So very quickly, let me re-sketch the entire region. Okay, so sometimes it happens. Be a little patient. Okay, so that's the region. Okay, so on a sketch of an Argand diagram, shade the region whose points will represent complex number z satisfying both my inequalities. So I'm going to just mention that this is the region satisfying both the inequations. So any point in this shaded region is going to satisfy both of the inequations. So that is how the solution set is going to look like. So I'll just quickly remove this particular part. Okay, so that was only there for the understanding purpose. So this is how the question is solved, and you have fetched another 4 marks. That was question number 2. We are now in a position to move ahead with the next question. So again, the next question is a pretty simple question, students. You have to make use of simultaneous equations. Okay, let's quickly take a look at the question. So the question says the variables x and y satisfy the equation x raised to n y square equal to c, right? That's the equation given to us. So the variables x and y satisfy this equation x raised to n y square equal to c, where n and c are constants. Okay, the graph of ln of y against ln of x is a straight line passing through the points. So the coordinates are given to us 0.31, 1.21 and 1.06, 0.91. These are the coordinates of the points, and as shown in the diagram. And you are told to find the value of n, and find the value of c correct to 2 decimal places. So you want to find the value of n and c up to 2 decimal places. So it's a pretty simple question, students. The graph is not given for the equation x raised to n y square equal to c. Instead, the graph is given for ln of y against ln of x. So you want to definitely take natural log. So I have my equation. X raised to n y square equal to c. X raised to n multiplied with y square equal to c. So you take natural logs on both the sides. Take natural log on both sides. So I get ln of x raised to n multiplied with y square is equal to ln of c. So don't you recall the basic properties of logarithms? Ln of a times b is equal to ln of a plus ln of b. So I can write here, therefore, ln of x raised to n plus ln of y square is equal to ln of c can be called as a new constant k if you have to. Okay, so I'll call it as k. Now, again, there is another very important property of logarithms which says that ln of a raised to m is equal to m ln of a. So the m comes down, isn't it? So I can have here the next step as n times of ln of x plus 2 times of ln of y is equal to k. Right, students? So now if I say that ln of x is taken as capital X and ln of y is taken as capital Y, wouldn't the equation look like n x plus 2y is equal to k? Isn't that a linear equation, right? Nx plus 2y is equal to k. It looks like ax plus by equal to c. It's a linear equation, and that's why you have a linear graph of ln of x and ln of y. So the question mentioned that the graph for ln of y against ln of x was a straight line, isn't it? This is the reason why it is a straight line, because after taking natural logs on both the sides for the given original equation, you got an equation which is a linear equation in ln of x and ln of y. That's why we have a straight line. Okay, fine. So this is the equation that we have got. And for this particular equation, which represents a straight line, there are 2 points on the line given to us, right? There are 2 points on the line. Which are given to us. These 2 points lie on the line. So if the 2 points are lying on the line, what will the 2 points do? Shouldn't the 2 points be satisfying the equation of the line, isn't it? So I'll write over here points 0.31, 1.21 and 1.06, 0.91 satisfy the equation. So I get n times of, so these values are values of ln of x and ln of y. So n times of 0.31 plus 2 times of 1.21 is equal to k, which is ln of c. Okay. So I can call this as my first equation, and the second equation is going to be n times of 1.06 plus 2 times of 0.91 is equal to k. That's my second equation. So I'm going to take the help of the calculator. Students, you should be very much aware how this calculation needs to be done. So you can observe your first equation is actually something like this. The first equation is 0.31 times of n minus k is equal to 2 times of 1.21. Okay, so I have taken all the variables on one side, and then I'll be having 1.06 times of n minus k is equal to, so I have made a small mistake in my first equation. So I have transferred k on the left. So this k has come on the left. This 2 times of 1.21 will go on the right. So it is not just 2 times of 1.21. So we are saved from making a possible blunder. So that's negative 2 times of 1.21. Good that I noticed it at the very beginning. So same is going to happen for the next equation. So this 2 times of 0.91 is going to go on the other side. K has come on the left. So I get negative 2 times of 0.91. So let's take the calculator and solve it simultaneously. So I go to the equation mode. Okay, I select a linear equation with 2 unknowns. So the first variable is n and the second variable is k. So the coefficient of n is 0.31 in the first equation. The coefficient of k is -1. So I plug -1 in my calculator. And the right hand side is minus of 2 times of 1.21. So -2 multiplied with 1.21. So there is no need to get separate answers for -2 into 1.21 and then keep on writing in your solution. That's just going to cost you time. Okay, your calculator can do all this stuff. You just want to enter the value -2 multiplied with 1.21 straight away in your calculator. Let's take the next value. You have 1.06, 1.06. Okay, that's the coefficient of n from the second equation. Coefficient of k is again -1 and the right hand side is -2 times 0.91. So you're going to solve them simultaneously. You have got the value of n. The value of n has come 4/5, or you can say 4/5 is going to be 0.8, right, students? So the value of n is 4/5 or 0.8, and the value of k has come. The value of k has come 667 divided by 250. So I'm not going to write the decimal value. That's the ln of k. That's the value of k. And you know that k is ln of c, right? K was ln of c. So that means I can say ln of c has the value 667 divided by 250. Look at the question. The question says find the value of n and find the value of c correct up to 2 decimal places. So n I am not worried about because it has come 4/5, which is definitely going to come 0.8. No further value, isn't it? Ahead of 8 I have. So it's straight away 0.8. But for the value of c, I need to take care. I need to write up to 2 decimal places. So I'm going to get c over here. So of course, I'll now first of all come out. I'll clear my screen for doing the next calculation. So I now need the value of c. So c is going to be e raised to, students, very important. You have taken natural logs. Okay, so you would take exponentials on both the sides. So e raised to ln of c is equal to e raised to 667 divided by 250 is what you are going to get. E raised to ln of c is simply c. Okay, so c is equal to e raised to 667 divided by 250. So what's the value of c? Let's quickly get it. So I go to the exponential term. I write 667 divided by 250. What's my answer? So the answer has come 14.4111812. So I just want to write up to 2 decimal places. See, it has been clearly mentioned in the question that you want to write up to 2 decimal places. So my answer is going to be what? 14.41. So the value of c is 14.41. So I have got the value of n and c. So n is 4/5, or you can say 0.8, and the value of c has come 14.41. So this is what the solution for question number 3 is. I hope you have understood the question pretty well, right, students? It's time for us to move on to the next question. So again, it's a lengthy paper, students. There are 11 questions that you want to solve. So you really want to be very patient while solving the entire question paper. Okay, so determination, dedication, patience, every single thing is needed for such a lengthy paper. So what do we have in the next question? The parametric equations of a curve are. So the parametric equations are given to you. Okay, I am pretty confident that you already know what a parametric equation is, right? So x and y are both depending on the variable theta, right? X and Y are both depending on the variable theta. Theta is your independent variable. X and Y are your dependent variables. So as you make any change in theta, there will be a change in X and Y. So theta is free to take its value. It will keep on changing, but the values of X and Y, they both depend on the value of theta. So when such kind of things happen, when two or more variables depend on one single variable, then we call the equations as parametric equations. So I have the parametric equations. What is asked is you show that dy by dx is minus 2 sine square half theta, or you can say theta upon 2. Now, I cannot see any more simpler question into the entire question paper. Okay, it's a very simple question. You just want to know your formulas very thoroughly. Students, I urge you to keep on memorizing the formula list, the trigonometric formulas. Although the formula list will be provided into the exam, but that will simply cripple you. Okay, it will take a lot of time to solve a particular question. Also, the logic building gets a little bit crippled. Okay, so I would strongly advise you that you know your formulas, you learn your formulas very thoroughly, and it's a simple task. Just keep on writing the formulas for a few days, and you will be thorough with all of the formulas. Okay, so it will pace up your thinking process. Okay, you don't have to keep on finding the formulas into the formula list. Okay, so that's the reason for me to ask you to learn the formulas. Okay, students. So x is given to you 1 minus cos theta, y is given to you cos theta minus 1 upon 4 cos 2 theta, and you are asked to get dy upon dx. So you know what parametric differentiation is, right? So if I want to get dy upon dx, both x and y are parametric equations of the variable theta, then dy upon dx is given by what? It is dy upon d theta whole divided by dx upon d theta. Isn't that true? Isn't it? So I am going to get dy upon d theta and dx upon d theta, and then place them into this particular differential coefficient, dy upon dx. Okay. So what's y given to you? It's cos theta minus 1 upon 4 cos 2 theta. So I'm going to differentiate both the sides with respect to theta. Let's differentiate both the sides with respect to theta. So differentiate both sides with respect to theta. So I get dy upon d theta is equal to d upon d theta of cos theta minus 1 upon 4 cos 2 theta. Now, I know you should definitely be knowing your differentiations, right? So derivatives is very important over here. Again, there will be formulas of derivative, there will be concepts of derivative, right? There is something called as a chain rule, the differentiation of composite functions, the differentiation of standard functions. Every single thing needs to be very clear in your mind. So I can see that there is a first term derivative of cos theta, and then there is a second term derivative of 1 upon 4 cos 2 theta. It's not cos theta, it's cos 2 theta. So the second function is a composite function, and the first function is just cos theta. It's a standard function. So what's the derivative of cos x, students? Don't you remember that a derivative of cos x with respect to x is minus sin x? Derivative of cos x is minus sin x. So will be the derivative of cos theta. The derivative of cos theta is going to be minus sin theta, right? So my first term is going to give me the answer as minus sin theta. Then I have minus 1 upon 4 derivative of cos 2 theta. So what's the derivative of cos theta? It was minus sin theta. So derivative of cos 2 theta is also going to be minus sin 2 theta into again the derivative of 2 theta, right? That's what the chain rule is. That's what the composite functions differentiation is, isn't it? I'm definitely aware that you are totally knowing this concept. So derivative of 2 theta is going to be 2. So on simplification, I'm going to get, so the second term is going to be what? It's now going to be positive. Minus minus becomes plus. The 2 and the 4 will cancel. So you get 1 upon 2 sine 2 theta minus sine theta. Now let's go a step ahead. can you write sine to theta? See, that's the power of knowing the formulas. Okay, you don't have to keep on going into the formula list and keep on finding what term has what formula. So sine to theta, and see, the logic building also happens automatically, isn't it? You don't have to put efforts to create the logic. The logic automatically comes into your mind. So sine to theta, it's 2 sine theta times cos theta. You can cross check if you're not knowing the formulas. Sine to theta is 2 sine theta cos theta minus sine theta. Now, can you cancel the 2? Can you cancel this 2? Can you also take out this sine theta common, isn't it? So sine theta is common. So I'm going to take out sine theta common. What is left? You're left with cos theta minus 1. Now, instead of taking cos theta minus 1, again, if I take out a negative sign common from cos theta minus 1, will it not look like minus of sine theta 1 minus cos theta? Now, students, I am totally aware of my answer. My answer should look like minus 2 sine square half theta, or I say theta by 2. Minus 2 sine square theta by 2. That's a half angle. Your question was in terms of theta. The question is in terms of theta, and the answer is expected in theta by 2. So from theta, you want to convert to theta by 2. That means you need to make use of your double angle formulas, or you say half angle formulas, right? You say double angle, you say half angle, it's one and the same things. So from theta, you want to come down to theta by 2. That means you definitely need to transform the given trigonometric ratios into half angles. Okay, so 1 minus cos theta. I don't know how much you know your formulas. Please learn them. Okay, if not, start practicing. If you're not aware of the formula, start writing the formulas on a regular basis. So 1 minus cos theta, students, is 2 sine square theta by 2. You can cross check. 1 minus cos theta is 2 sine square theta by 2. So I get my answer as minus of sine theta times 2 sine square theta by 2. So that's the term that I'm looking for, 2 sine square theta by 2. I just want to take care of the sine theta that is present over there and the negative side. Let's see what happens with that also. So that was the derivative of y. I've got dy upon d theta. Now it's time for us to differentiate x. So what is x given to you? It's so simple, 1 minus cos theta. So I'm going to differentiate both sides with respect to theta. So I get dx upon d theta is equal to d by d theta of 1 minus cos theta. So what's the derivative of 1? It's going to be 0. Then a negative sign. What's the derivative of cos theta? It's going to be minus sine theta, right? It's a standard function. So the answer simply comes sine theta, right? The answer is simply sine theta. That's dx upon d theta. Now, can you get dy upon dx, students? The answer is yes, I can get dy upon dx. So therefore, dy upon dx is dy upon d theta, that's negative sine theta times 2 sine square theta by 2 whole divided by dx upon d theta, which is simply sine theta. I can definitely see a sine theta in the numerator and in the denominator. Sine theta cancels, and you are left with what? Isn't that your answer? So dy upon dx is minus 2 sine square theta by 2, or you say half of theta. That's how you have fetched another 5 marks for this particular question. Right, students? Very simple question, isn't it? So that was 4th question. See, we are inching towards the completion of the paper. Although I know the question paper contains 11 questions, but now we are on to the 5th question. And again, students, even the question looks for, it's given there for 6 marks. It might look complicated, but believe me, it's pretty simple. It's not a difficult question. It's an easy question. Okay. What is needed is you knowing the formulas, okay, of the trigonometry. Formula list must be very clear in your mind. So the angles alpha and beta lie between 0 degrees and 180 degrees. So that's your first and the second quadrant, right? 0 degrees and 180 degrees. So the angles are given in degrees. Okay, so let's quickly make the first and the second quadrant. So I have this as 0 degrees. I can just extend this line a little bit. Okay. And then I have this 180 degrees. So first and second quadrant. So theta is lying between the first and the second quadrant. Okay. Then it is said the angles alpha and beta lie between 0 and 180 and are such that tan of alpha plus beta is 2. Tan of alpha plus beta is 2 and tan of alpha is 3 times of tan beta. Find the possible values of alpha and beta. So students, the question is for 6 marks. And I'm telling you, fetching this 6 marks is very simple. So I begin with tan of alpha plus beta. So I have two equations. See, my question contains two unknowns, alpha and beta. So for two unknowns, I need two equations. Two equations are already provided to me. I begin from the first equation. So I have tan of alpha plus beta is equal to 2. So I write over here, tan of alpha plus beta is equal to 2. So now what's the formula of tan A plus B? Students, tan A plus B, isn't it tan A plus tan B whole divided by 1 minus tan A tan B? So tan of alpha plus beta is going to be what? It's going to be tan alpha plus tan beta whole divided by 1 minus tan alpha times tan beta, and it is equal to 2. Okay. Now I also know that tan alpha is equal to 3 times of tan beta, right? If tan alpha is 3 times of tan beta, can I substitute this equation, tan alpha, into this equation? So in place of tan alpha, I can plug the value of tan alpha as 3 times of tan beta. So I'm going to do that. So therefore, in place of tan alpha, I'm placing 3 tan beta. So I get 3 tan beta plus tan beta whole divided by 1 minus. So the tan alpha is what? 3 tan beta into tan beta is equal to 2, right? So that gives me 3 tan beta plus tan beta. That's 4 tan beta whole divided by 1 minus 3 tan square beta is equal to 2, right? So it's going to be a quadratic equation of tan beta. So students, for some time, what I'm going to do here is I'm going to plug tan beta as m. Okay, let's write tan beta as m. So I get 4m divided by 1 minus 3m square is equal to 2. Let's simplify this. So I get 4m is equal to 2 times of 1 minus 3m square. So that's 2 minus 6m square. Let's collect all the terms together. So I will have 6m square plus 4m minus 2 equal to 0. You can clearly see that every single term is a multiple of 2. So I can divide throughout by 2, isn't it? So I get 3m square plus 2m minus 1 equal to 0. So that's my quadratic equation, which I want to simplify. The coefficient of m square is 3. It goes and multiplies with minus 1, right? So 3 multiplies with minus 1. So I'm going to get minus 3 over there. So the factors of minus 3 as if to get a plus 2. Okay, the factors of minus 3 want to tell as if to get a plus 2. So it's going to be simply plus 3 multiplied with minus 1. So that's plus 3 minus 1. We're going to get 2. So I have 3m square. I have 3m square plus 3m minus m minus 1 equal to 0. So I can take out 3m common from the first two terms, right, students? And what is left? M plus 1. I can take out a negative 1 common from the next two terms. I'm left with m plus 1. So I get m plus 1 multiplied with 3m minus 1 equal to 0. So yeah, plenty of space is there. That means I can write either m plus 1 is 0 or 3m minus 1 is 0. That gives me m equal to minus 1 or m equal to 1 over 3. But what was m, students? M was tan beta. So therefore, tan beta is going to be negative 1, or I can say tan beta is going to be 1 upon 3. Now tell me, if tan beta is negative 1, don't you know that tan alpha was 3 times of tan beta? I can write here, but tan alpha was 3 times of tan beta. So if tan beta is -1, what would be tan alpha? Tan alpha would be 3 times of tan beta, which is -1. So -1. So I get tan alpha as -3. Similarly, when tan beta is 1 upon 3, so I get tan alpha as 3 times of 1 upon 3, 3 times of 1 upon 3. So I get tan alpha as 1. So students, tan alpha is -3, tan beta is -1, or tan alpha is 1 and tan beta is 1 upon 3. So can you guess from here that the first set of answers, tan alpha, tan beta, both of them are negative, right? Tan alpha, tan beta, both of them are negative. Now, are you aware that the trigonometric ratio tan is negative in the second and the fourth quadrant, right, students? Second and the fourth quadrant, the trigonometric ratio tan is negative in the second and the fourth quadrant. I know alpha and beta are both lying in the first and the second quadrant. 0 to 180 is the range for alpha and beta given to me. So there is no point of alpha and beta going into the fourth quadrant. So that discussion will not come. So from the first set, I can see tan alpha, tan beta, both of them are negative. That means alpha and beta are going to lie in the second quadrant. So I'm going to get the value of alpha. So of course, alpha would come tan inverse of -3. Now you want to be very particular about this particular answer. So tan alpha was -3. So tan inverse of -3. Now, students, I'm going to get the values in degrees. Why I'm going to get the angles in degrees? Because it said that alpha and beta lie between 0 degree and 180 degree. The question specifies the units of alpha and beta, right? They are in degrees. So let's get the answer in degrees. So we are going to write the answer up to 1 decimal place. So now if you put -3 over there, tan inverse of -3, your answer, see, the angle is in the second quadrant. If the angle is in second quadrant, the angle needs to be more than 90 degrees, right? Let's try the value, tan inverse of -3. So if you get the value of tan inverse of -3, it's going to be -71.565. The answer is -71.565. That is not the angle in the second quadrant. That's the angle of the fourth quadrant, student. So when you say minus, it means there will be a clockwise rotation, right? There will be a clockwise rotation. So this is the most important thing you want to really understand. So there is a clockwise rotation of the angle. So let's very quickly make alpha over here. So this value is -71.656. So what you do is you just extend this line. You just extend the line which is in the fourth quadrant will be extended into the second quadrant, right? So this angle is 71.56 or 656. I'm so sorry. It's 71.565. So I want to get this angle, isn't it? So it's going to be 180 minus 71.565. So you just write this as 180 minus 71.565. So I just add plus 180 to it. So it's 108.435. But as you know, I just want my answer up to 1 decimal place. Nothing is mentioned in the question. So I should go to my instructions, which are given on the very first page. So I need to write my answer up to 1 decimal place for an angle which is mentioned in degrees. So alpha has come 108.4 degrees. Okay. So that's one of the answers. Let's get beta also. So I'm going to get beta now, students, very quickly. Okay. I'm going to get beta. So let's write for beta. Beta is going to be tan inverse of -1. If you are already aware of some standard angles, you need not make use of calculator. Do you know that tan of 135 degrees? tan of 135 degrees is -1. So without using the calculator, you can get that answer. Okay. Of course, if you are not aware of the answer, go to the calculator, get tan inverse of -1. It will come -45. -45 is an angle in the fourth quadrant. Stretch it to the second quadrant, and you just get the value of beta. Okay. And or you can do just 180 minus whatever angle you have got. So this is going to be simply 135 degrees. So beta has come 135 degrees. That's one set of values. Alpha and beta is what I've got. Now let's work out on the second set as well. Let's work out on the second set as well. Okay, so I'm going to get the second set now. Fine, students. So here, so simple, tan alpha is 1. So if tan alpha is 1, what's alpha going to be? So alpha is simply going to be tan inverse of 1. So tan alpha and tan beta are both positive. Tan alpha, tan beta are positive. Tan is positive in the first and the third quadrant. Clearly mentioned, alpha and beta lies from 0 to 180. No chance of angles going in the third quadrant. So alpha and beta are definitely lying in the first quadrant this time. What's tan of 45 degrees? Don't you know that tan of 45 is 1? That means tan inverse of 1 is going to be 45 degrees. So alpha is going to be 45 degrees. So that's another set of values. Alpha is 45 degrees. And then I have tan beta is 1/3. So beta is going to be tan inverse of 1/3. This time the answer is definitely going to come acute. So I'll just get tan inverse of 1/3. So the answer came 18.4349. I just want to write up to one decimal place. So it's 18.4. Okay, it's 18.4 degrees. So I've got the value of beta as 18.4 degrees. So that's my another set of values. So alpha is 45 and beta is 18.4 degrees. So one set of values is lying in the first quadrant and one set of values is lying in the second quadrant. So students, isn't the question very simple? And you have fetched another 6 marks for this particular question, question number 5. It's time for us to move to the next question. So in the next question, which is going to be question number 6, let's see what the question is. So we are inching towards the half mark, right, students? We have 11 questions to be solved. We are now on to the 6th question. So find the complex numbers W. So you can read it as W, you can read it as omega. Okay, I'm going to read it as omega. So find the complex numbers omega, which satisfy the equation omega square plus 2i omega star. So that star over there signifies it's the conjugate of omega. So I'll read it like omega square plus 2i omega prime or conjugate of omega. So omega square plus 2i omega prime is equal to 1 and are such that real part of omega should be less than or equal to 0. So very important condition, students. You want to keep this in mind. Real part, Re omega, it means real part of omega. Omega is a complex number. Omega is a complex number. It should be written as alpha plus I beta. Alpha is your real part. Beta is your imaginary part, right? So it is told that the real part should be either 0 or less than 0. Okay, so it will be negative answer. So omega, real part of omega is less than or equal to 0. Give your answers in the form x plus I y, where x and y are real. Let's quickly start with the question. So as I said, omega is going to be what? Omega is going to be x plus I y. So let's write that way. Let omega is taken as x plus y. So how much space is available for this particular question so that we can plan? Okay, so one entire page is available to write the solution. So omega is x plus I y. And what's the equation given to us? The equation is omega square plus 2i omega prime is equal to 1. Okay. So place the value of omega. That's it. So it is x plus I y the whole square. See, you want to get the value of omega in terms of x plus I y. So you will need the value of x, you will need the value of y, which are two unknowns, right? So you want to get the values of x and y, two unknowns are there. You need two equations. You have to get these two equations from somewhere. So I want to place the value of omega. The value of omega is x plus iy. So x plus iy the whole square plus 2I omega prime, that's x minus iy, conjugate of omega, right? You want to change the sign of the imaginary part. So x minus iy is equal to 1. So first part, x plus iy the whole square is a plus b the whole square. Simplified, you get x squared plus 2xiy plus I square y square plus 2ix minus 2I square y is equal to 1. Now you can observe that this term is I square, this term is I square. Don't you know that I square is -1? So you get x square plus 2xyi. I square is -1. So it's going to be minus of y square plus 2xi. Again, I square is -1. So minus of minus becomes plus. That's plus 2y is equal to 1, right? So now you can observe there are two terms. There are two terms which are terms of I. Can you see this term and this term? There are two terms of I. And there are three terms, x square minus y square, right? X square minus y square, and this 2i. They are all terms which are without I. So terms which are without I will contribute towards the real part, and the terms which are with I will contribute towards the imaginary part of the complex number. So that's what you need to do now. You want to start collecting the real terms and the imaginary terms. So I get x square minus y square plus 2y plus, I can take out the I common and write 2xy plus 2x. Now you have an equal to sign in between. There is a left hand side, there is a right hand side. Okay, so in the left hand side you have an imaginary number. If you have a complex number of the form u plus iv, right? So the right hand side should also be a complex number of the form a plus ib. So I have 1. Can you write that 1 as 1 plus 0i, right, students? So you just want to compare now. So compare real and imaginary parts. So I get x square minus y square plus 2y as 1. That's my first equation. And 2xy plus 2x as 0. That's my second equation, right? So I'm going to take the second equation because the second equation is slightly simpler than the first equation. I want to solve the two equations simultaneously, but that's not the case over here. The first equation is a second degree equation. The second degree equation is also, the second equation is also a second degree equation, but they are slightly complicated. So I'm going to start with the second equation. Observe from equation 2 what we can do. So I can write from equation 2, is it okay to take out a 2x common? Can you take out a 2x common and you are left with y plus 1 equal to 0. That gives me either 2x is 0, that is you can simply say x is 0. So I'll write that way. X is 0. Instead of writing 2x equal to 0, let's write x equal to 0. So therefore either x is equal to 0 or you can say y plus 1 equal to 0, isn't it? Y plus 1 equal to 0. That is y is equal to minus 1. So I have two more values of now x and y. X is 0 or y is -1. So you begin from x equal to 0. You plug this value into the first equation. So plug x equal to 0 in first equation. Don't write like this. Plug x equal to 0 in equation 1. So that's 0 square minus y square plus 2y is equal to 1. That gives me y square minus 2y plus 1 equal to 0, right? All the terms are transferred on one side. So you get y minus 1 the whole square equal to 0. That means you get y is equal to 1, right? So when x is 0, I've got the value of y as what? 1. Do you recall x is the real part of omega? X is the real part, y is the imaginary part. Omega was x plus iy. So I know that the real part of omega needs to be what? It needs to be less than or equal to 0. You remember the condition, right? I've already made you aware of that condition at the very start of the question. Real part of omega is less than or equal to 0. So the real part of omega, which is x should be less than or equal to 0. So I've got the value of x as 0, right? The value of x as 0. And at that time, the value of y has come 1. No conditions are imposed on y. So y can be equal to 1. So x is 0 and y is 1. So let's quickly write omega also. So therefore, omega is going to be what? Omega was x plus iy. X equal to 0 is an allowed value of x. So it becomes 0 plus I times of 1, or it's simply I. So omega has come I. That's my first answer, students. Omega equal to I is my first answer. So this answer I've got by plugging the value of x as 0. I have one more value, y is equal to negative 1. I'm going to use that value also. So I'm going to plug the value of y now. I'm going to plug the value of y. And the value of y has to be taken how much? It has to be taken negative 1. So let's begin for the second set of values. So plug y as minus 1 in again the first equation, right? We are just solving the first equation here. So it was x square minus, it is x square minus y square, but y is negative 1. So the square of negative 1 plus 2y. So 2 times of y is negative 1 is equal to 1. So that should give me x square minus 1 minus 2 equal to 1. So x square would come. So minus 1 minus 2, that's minus 3. It goes on the other side, becomes plus 3. 1 plus 3 is 4. X square is 4. So the value of x is plus or minus 2. Are both the values correct, students? X equal to plus or minus 2. Think about it. Are both the values correct? X is not plus and minus 2. It's just one value, because you remember the real part of omega should be less than or equal to 0. So from there, I can say, but x needs to be not greater than, it needs to be less than or equal to 0. So therefore, x would come minus 2. So what would be omega now? So I know that omega was x plus iy. The value of x is negative 2. And the value of y, do you recall? Was it negative 1? Isn't it? So y was negative 1. X has come negative 2. So the value of omega is going to be x plus iy. X is negative 2 plus I, y is negative 1. So that's minus of I. That's the next value of omega. So I've got two different answers for omega. So omega is I, or it is minus 2 minus I. So see, again, a very simple question, isn't it? And you have fetched 6 marks for this question. So students, it's time for us to move ahead. The half mark is crossed. We have completed 50% of our paper, right? So now we are on to the 7th question. Okay, the first question says what? The first part of the question A, by sketching a suitable pair of graphs, show that the equation 4 minus x square is equal to sec of half x. Sec of half x is like sec of x upon 2. Has exactly one root in the interval x lying between 0 to pi. Now, can you see x is greater than or equal to 0, but it is less than pi. Okay, so it's not less than or equal to pi. So on the right side of the interval, there is no equality present. So x cannot become equal to pi. It has to be less than pi. Okay, so let's proceed. I have two different equations over here. See, the question says by sketching a suitable pair of graphs. When you say pair of graphs, what do you mean? Pair of graph means there should be two graphs, right? So you want to draw two graphs. Then you want to decide now whose graph are you going to make. So you want to see, you want to show that the equation 4 minus x square and sec of half x has exactly one root. These are my two equations, isn't it? So 4 minus x square becomes my one equation, and sec of half x becomes my second equation. So I want to see these are two equations which are equated with each other. There must be some value of x for which the LHS and the RHS will become equal. There will be one value of x which, when substituted into the equation, the left hand side and the right hand side of the equation should become equal. I want to find that value of x, and I want to show that there is exactly one value which is lying between 0 and pi. There might be more values after the given interval, but I have to check for the given interval from 0 to pi. Okay, so that's a pretty easy stuff. So how do I begin? See, so there are two different equations that I have. There are two different equations. One is 4 minus x square, and the other one is sec of half x. These are the two equations. So let's consider y as 4 minus x square. Right, students? Y equal to 4 minus x square. Now, what is x lying between 0 to pi? Do you know that pi is 3.142? Pi is 3.142, and you know that x cannot take the value pi. It has to be less than pi. So less than pi, it can be anything, 3.141 also. Okay, so if I take the values of x as, so it needs to start from 0, and x can become equal to 0. So you can take 0, 1, 2, and 3. These many points are enough to plot the graph of y. It's a second degree equation, students. Have you realized that? It's a second degree equation. Second degree equations in general will form parabolas. So y equal to 4 minus x square is going to be a parabola. Okay, so let's find out the points. It's going to be a curve. It's going to be a parabola. Let's see what kind of parabola it is. Is it a U-shaped parabola? Is it an N-shaped parabola? What? So I can clearly understand that the coefficient of x square is negative over here. That means it is going to be an N-shaped parabola. It's going to have the maximum point. So let's check. So if I plug the value of x as 0, I get a 4. I plug the value of x as 1. Then the value of x as 2 and 3. So let's check whether it is the U-shaped parabola or the N-shaped parabola. So the coefficient of x square definitely decides the shape of the parabola. Okay, so I can have here 4 minus x square. So I'm going to plug the value of x as 0. So I get y as what? Y becomes equal to 4 when it is 1. X square is x is 1. So I get 4 minus 1. That's 3. Then 2 square, that's 0. Then 3 square, so 4 minus 3 square, that's 9. 4 minus 9, that's negative 5. So I've got the values as 4, 3, 0, and negative 5. That means I want to go on the y-axis till minus 5. So I'm going to draw a vertical line over here first of all. Let's draw a vertical line. Okay, so this vertical line is your y-axis. And then I'm going to draw the x-axis also, 0, 1, 2, 3. Okay, and then of course 3.142, that's pi, which is going to lie between 3 and 4. So and on the y-axis, I need 4, 3, 0, and minus 5. So better I'll do it like this. That's my x-axis. Okay, so x-axis need not go very far. So that's 0, 1, 2, 3, and 4. So 3.142 is very close to 3. So this is where pi is going to be. That's pi. Okay, that's pi. So I'll just quickly write it over here. That's pi. That's 3. That's 2. That's 1. And then I'll take values on the y-axis as well. So I want to go in the positive direction till 4 and in the negative direction till minus 5. So I'll take, this is 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4, negative 5. So very quickly write the values. So that's 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, and negative 5. You got that? Okay. So for x as 1, for x as 0, the value of y was 4. So the very first point is going to be here, right? So that's 0, 4. The next point is when x is 1, it is 3. So it's going to be somewhere here. Okay. Then the next point is 2, 0. So x is 2 and y is 0. It's here. Got that? And the next point is x is 3 and y is -5. So it's somewhere here. Okay. So as I said, it's going to be an N-shaped parabola. Let's see whether I'm able to make it or not very properly. So let's make the graph. A very proper graph, students. Okay, the more precise diagram you make, the more correct answers you'll be getting. Okay, so that's how the graph of y equal to 4 minus x square is going to look like. So can you observe that the coefficient of x square was negative? So it's going to be an N-shaped parabola. The graph is going to have a maximum value. So we can confirm this. Okay, so when the coefficient of x square is negative, it's going to be an N-shaped parabola. So you'll have a maximum. So it's going to be like this. It can go further and it becomes like this. Okay, of course, we are not interested in the rest of the part of the graph. We only wanted the graph that is lying between 0 and pi. Okay, so in fact, I have not taken the value of pi also here. Up to 3, it is enough. So this graph is y is equal to 4 minus x square. Now it's time for us to start solving the second graph. So second graph is y is equal to sec of x upon 2. So y is sec of x upon 2. So again, x is going to lie from 0 to pi, right? So I can take 0, 1, 2, 3 and so on. But instead of taking 0, 1, 2, 3 and so on, I'm going to take 0, pi by 2 and pi. Now, students, can you understand pi by 2 is 3.142 divided by 2. So it's somewhere around 1.6 or something like that. So it is going to be somewhere here, right? That's pi by 2, students. That's pi by 2. And you already have the value of pi here, isn't it? This is pi. I know the value of pi is here. So I'm going to take three values, 0, pi by 2 and pi. That will be enough. 0, pi by 2 and pi. So x is going to be 0, then pi by 2 and pi. So y would come sec of x is 0. So sec of 0, that's 1. Then y is going to be sec of. Now x upon 2. X is pi by 2 upon 2. So that's pi by 4. Now, do you know that cos of pi by 4 is 1 over root 2? So I get sec of pi by 4 as root 2. So I write here root 2. And then y becomes equal to sec of pi by 2. Now remember, x is not going to take the value of pi, isn't it? It will be a very close value of pi. But let's try and understand what is the value of sec of pi by 2, because I've taken the value of x as pi. Let's see what the answer comes. So you know that cos of pi by 2 is 0. So sec of pi by 2 would come infinity. And that's the reason x is not going to become pi. So it is equal to infinity. So the graph will go up to infinity. So at x equal to pi, you will find an asymptote. Okay. You're going to get an asymptote. Although that's not needed. Okay. You don't need to draw the asymptote. But maybe if you draw it, that's all right. Okay, so that's an asymptote. Okay, so the graph of sec of x by 2 will not go beyond this line. It's not going to go out of this line. So I'm going to start for the graph of sec x. Okay, so how the graph is going to come? So for x equal to 0, the value of y is 1. For x equal to 0, the value of y is 1. So it's going to be here, right? That's 0, 1. For x equal to 0, y is 1. Then for x equal to pi by 2, the value is root 2. So it's 1.414. So it will be somewhere here, let's say. Okay. And for pi by 2, it's going to be infinity. So it will simply stretch, right? So the graph is going to go like this, and then it will become almost parallel to the asymptote. Okay, it will become almost parallel to the asymptote. So I'll just draw it that way. It is not going to intersect the asymptote. It will just keep on coming closer and closer to the asymptote. So the asymptote was x equal to pi. So again, I'm telling this is not needed. Okay, so can you see that the two curves, the red colored curve and the purple colored curve, are both intersecting at exactly one point, isn't it? See, this is that point, isn't it? This is the point of intersection. This is the point of intersection of the two curves. And how many points of intersection you have got? Only 1 point. That means by drawing the two graphs, I can clearly understand that the two graphs are intersecting each other at exactly 1 point. So there will be exactly one root which is lying between the interval 0 to pi. Okay, there might be another root as well. Who knows, isn't it? If you extend the graph for remaining limits as well outside 0 and pi, the graph might intersect at some other point as well. But that's not our worry at this moment. It's not our concern at this moment. We just want to check by drawing the two graphs whether the graphs are intersecting at 1 point or not for the given range, for the given interval of x. And I can see by the graph, it is definitely very clear to me, right? So that was the first part of the question, students. 7A, although it's for 2 marks, but it has taken some time to solve. For this, you need to be very much aware of the graphs, how to draw the graphs. So the knowledge has to be there with you. Now, verify by calculation that this root lies between 1 and 2. So it's very simple now, students. So I'm going to follow again the first method of getting the answer. You have the two equations with you, the left-hand side and the right-hand side. Okay. So the left-hand side, right-hand side that you have, you just want to plug the value of x as 1 and then the value of x as 2. If there is a sign change between the two equations, you will say that the root lies between 1 and 2. So you can clearly observe from the graph also that the root is lying between 1 and 2. So our equation is 4 minus x square. 4 minus x square is equal to sec of half x, or you write x upon 2. So let's plug the value of x as 1. That's the easier method. The first method is the easier method. The second method is you collect all the terms of x on one side, okay, and equate it with 0. So that becomes f of x equal to 0. Now you plug the value of x as 1, plug the value of x as 2. For one value, this f of x will give a negative answer. For one value, it will give a positive answer. So negative, positive. So f of x is like y. It's the value of y. Okay. So if one value is negative, one value is positive for y. So from negative region, you're going to the positive region, right? From negative region, you're going to go to the positive region. So when the graph goes from negative to positive, it has to intersect the x-axis at some place, right? For some value of x, the value of y is going to be 0. So when you start from negative value of y and you are going to go to the positive value of y, in between, you will reach at one place where y is going to become 0 when the crossing is going to happen, right? This is the point where the function is having its root. Okay, so one value negative, one value positive comes. So that's one method of getting the answer. But the first method is far more easier. So you just plug the value of x as 1. Okay, plug x as 1. So I get 4 minus 1 square. I'll initially write equal to sign, equal to sec of x is 1. Now you've got to be very careful over here. X is plugged as 1. So sec of x by 2 is in radian. Students, take your calculator, and first thing that you should be doing is transform the calculator into the radian mode. Usually the calculators are in degree mode. So the first thing that you should be doing is transform the calculator into the radian mode. So I switch it on. I go to shift and setup, right? Press shift and more button. So you get shift and setup, and on on the fourth option, you have radian. So just press 4. The calculator will transform into the radian mode. It will shift to the radian mode. So I get here 4 minus 1 is equal to sec of half. So 4 minus 1 is 3 and sec of half. So I cannot get sec of half. So what I'll do, I'll get cos of half. Let's get cos of half and then do the reciprocal of it. So 1 divided by cos of 1 by 2. Right, students? So that's 1.13949. So 1.395. So is 3 greater than 1.395? So I'll put a greater than sign over here. Okay. So that's the first thing that I'll be taking care of. That's the first thing. Okay. First inequation that I've got. Now you plug the value of x as 2. So what do you get? 4 minus 2 square is equal to sec of 2 over 2. So that's sec of 1. 4 minus 4 is equal to sec of 1. Right? Sec of 1. So again, I don't know the value of sec of 1 because the calculator cannot give me sec, but it can give me cos. So I'm going to get 1 over cos of 1. So 4 minus 4 is going to be 0. And let's not put the sign over here. Let's first get the value of sec of 1. So I'm not going to get sec of 1 from my calculator. I can get cos of 1. So I'm going to get cos of 1. And I'm going to take the reciprocal of cos of 1. So cos of 1, I get some value. I take the reciprocal of that value. It's 1.8508. 1.8508. Now, 0 and 1.8508, what's the relation? Is 0 less than 1.8508? So I write here, 0 is less than 1.8508. So from the second outcome, I can see that there is a sign change, right? The first relation I had a greater than sign. The second relation, there is a less than sign. So there is a sign change. So this is the easier way of getting the answer. If there is a sign change by plugging the values of x which are given to you, you can definitely say that the root is lying between the given values. So here the root lies between 1 and 2. So I can say, since there is a sign change, a root lies between 1 and 2. Right, students? So we have proved this. So now it's time for us to move on to the next question. The next question is the C part. Students, in the C part, you are asked, use the iterative formula xn plus 1 is equal to under root of 4 minus sec of half xn to determine the root correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Okay. So in such type of question, the question is for 3 marks. In such type of questions, what I recommend is you take the calculator and form an equation in the calculator itself. Okay. So that will save a lot of time. So your solution will be very quick. So how do I make an equation? I'm going to teach you that. Okay, you want to follow my instructions, you want to make use of the calculator. So I'm using this FX991 ES plus. That's a calculator that I'm using. It's an old one, but it serves a purpose well. Okay, so of course you have the advanced calculators also. You can make use of the graphic display calculator as well. Everywhere the steps are going to remain exactly same. So I'm going to guide you how to form an equation into the calculator. With the help of that equation, you are going to find the iterations. Okay, so what is given to us? You are given that xn plus 1 is equal to under root of 4 minus sec of half x raised to n. Okay, not x raised to n, sorry, xn. And you want to find the root correct up to 2 decimal places. And in every iteration, you should go up to 4 decimal places. Now, first of all, do you remember that for this particular question, the root lies between 1 and 2? Is that right? Isn't it? The root lies between 1 and 2. It has already been verified by calculation in the first part of the question that the root is going to lie between 1 and 2. So your xn, so the very first value, the initial value, we call it as x naught. The initial value is called as x naught. So this value x naught can either begin from 1 and it will advance towards the root. Okay, or this x naught can be taken as 2 and it will again advance towards the root. So root is between 1 and 2, right? So it can be either 1.5 or 1.6 or 1.7 or any other random value between 1 and 2. So if you begin from 1, it will start advancing towards the root in the right direction, and if you begin from 2, it will start advancing in the left direction. Okay, so it does not matter whether you start with the value of x naught as 1 or 2. Okay, so I'm going to start with the value of x naught as 1. So I have xn plus 1. Students, xn plus 1 is given to us. Okay, so xn plus 1 is equal to under root of 4 minus sec of half xn. So I'll just write it over here. So I have xn plus 1 is equal to under root of 4 minus sec of half xn. Okay, so when n is 0, what will happen? So when n is 0, at that time I get x1. Okay, so it has incremented from x0 to x1. So x1 would become equal to under root of 4 minus sec of half x0. So what is the initial value you are going to begin from? The value of x0. So I'm going to take x0 as 1. Okay, x0 is going to be 1. So therefore xn would come out to be. So as I said, I'm going to make use of the calculator, and in the calculator I'm going to form an equation. Okay, so the very first thing that I'm going to do is, I know that the calculator is not capable to give me the answer of sec, right? The calculator cannot give me the answer for sec, but can it give me the answer for cos? Yes, it can give me the answer for cos. So is it okay to write this particular expression that you have as under root of 4 minus 1 over cos of xn upon 2, right? Half of xn, so that's xn upon 2. So the first thing that you should be doing is now press the square root sign. So you can see I have pressed the square root sign. Okay, so you want to form that equation, the expression 4 minus 1 over cos of xn upon 2. Right, students? So I'm going to write 4, then a negative sign, then it is 1 over. So I'm going to put the this fraction key. So there is this box upon box that you can have. So you can see there is this key, which is the fraction upon fraction. Okay, so box upon box, which is a fraction. So in the numerator you are going to enter 1, and in the denominator you are going to enter cos. In the denominator you're going to enter cos, and then you have xn upon 2, right? So xn is your unknown. Xn is the value that you're going to feed into the calculator. So press the alpha key. So you can see this is the alpha key. This is the alpha key. So press that alpha key, and then press this close bracket key. This is the close bracket key on which you can see x is written over there. So you can write this x over there, and then divide by 2, close your bracket, and navigate to come outside the square root sign. Navigate to come outside the square root sign. So this is how you will form an equation into the calculator. I hope, students, this is pretty much clear to you all how to form an equation into the calculator. So the steps are going to remain same whichever calculator you make use of. So this is the equation that will be able to see in your calculator. Now I do not know how this image is going to be seen. It is the first time that I'm showing this calculator on the video, so it might be a mirror image. Okay, just observe, just follow the steps that I have asked you to. So now what you need to do is you want to enter the values of x. Okay, you want to enter the values of x. So I'm going to press the calc button now. So you can see the calc button is over here, right? You are going to press the calc button, and the calculator will ask for the value of x. So the calculator is asking you to feed the value of x, and you are going to start with the value of x as how much? The value of x is going to start with 1. Now, do not worry about this particular answer over here. It does not matter what the answer is given over here. It is just the answer from the previous calculation. So you should not worry about that value over there. So it can be sometimes 0, sometimes some value would be there. Okay, but then we are going to start fresh. The calculator is going to start fresh. Do not worry about it at all. Now, one most important thing I want to mention over here is that keep the calculator in the radian mode. Students, can you see that in the expression you have a trigonometric term, right? There is a cos term or there is a sec term. So this trigonometric term has an angle, and that angle needs to be measured in radians. The value of x, sec of xn upon 2. So sec of xn upon 2, xn is taking the value as 1, 1.1, 1.2 and so on, keep on going up to 2. So this value of xn is in radians and not degrees. The most important thing, students, in this discussion that we are doing over here. Remember, whenever a trigonometric expression is involved, a trigonometric term is involved, then you should always keep your calculator in the radian mode. Okay, so most important thing, students. So now I'm going to plug the value of x as 1. So just enter 1, nothing else you do. So it was asking for the value of x. I have given the calculator the value of x, and that's 1. Okay, and then simply press the equal to sign. So the value has come 1.6913030069. So I want to write up to 4 decimal places. So it's going to be 1.6913, 4 decimal places. Okay. Now this x1 value is the next value that we'll be using for the second iteration. So x1 is 1.6913. So you're going to get x2 now. So you have plugged the value of n as 1. Okay, n is 1. So it's going to become x2 is equal to under root of 4 minus 1 over cos of x1 divided by 2. So again, you need not be writing the entire equation into the calculator. The equation is already there in the calculator. You are just going to enter the values of x. Okay, so now the value of x. So again, you want to press the calc button, students. You want to press the calc button. Okay, so let's press the calc button. Understand that value of x is going to be 1.6913, right? And then can you see the previous value was 1, the value 1 was entered, that's why it is showing 1. You should not worry about what that value is. Okay, you are going to enter the value of x as 1.6913. So the answer this time is coming 1.5788689. So I'm going to write up to 4 decimal places. So 1.57868 is going to become 7. 1.57887. So that becomes the next value. So I have taken 2 iterations. The question is for 3 marks. Okay, so I still need to go further. So now I'm going to plug the value of n as 2. So I get x2 as 1.5787. I'm going to get x3. So you need not be writing all these steps, students. You can simply write the values of x1, x2, x3 and so on. So this is cos of x2 divided by 2. So I'm going to again press the calc button. This time I'll enter the value as 1.5787 and answer is coming 1.606289. So that can be written as 63. Next value is going to be x4. Okay, now I'm going to write the answers directly. So press the calc button, enter 1.6063. The answer is 1.599999 and so on. So 1.5999, 4 decimal places. Now I'll get x5. So I'm going to enter, again press the calc button and enter the value of x as 1.5999, 4 decimal places you're going to enter. So the answer came 1.6015. 1.6015. I'll again continue further for x6. So I'm going to again press the calc button every single time. Whenever you're going to enter the value of x, press the calc button and then enter the value of x. So 1.6015 is the next value. I've got 1.6011. This is the place where I'm going to stop. Why? Because x5 and x6 have given me 2 decimal places same, right? 1.60, 1.60. So when you get 2 numbers, 2 digits after the decimal, same. After the decimal, two digits are going to be same. That is where you're going to stop your iteration and you're going to write your answer. So therefore, I can say the root is how much? The root is, and the root needs to be written up to two decimal places, right? So two decimal places, 1.60. So therefore, I can say x is 1.60. That's your answer, students. This is how the question needs to be solved. Now, you might feel that the question was too lengthy, but believe me, it's not lengthy. Once you form the equation in your calculator, that's the important part. You want to pay attention for that, how to form an equation in the calculator. Once you are done with that, what you need to do, you just need to plug the same value that you have obtained into the calculator. Okay, so I started from the value of x as 1. I got some answer. That answer was again fed into the calculator for the next answer. The next answer was again fed into the calculator to get the next answer, and I'll keep on doing this. Okay, so there are no need to write the steps that I've mentioned into the solution. It is only for explanation purpose. You can simply write x1 was 1. Okay, x2 came, so not x1 was 1, x0 was 1, x1 came 1.6913, then x1 was taken as 1.6913, you got x2, then x2 was taken that value and you got x3 and then x4 and then x5 and so on. You'll keep on continuing until two decimal places are same. Once you get two decimal places same, that is where you are going to stop your iteration. So believe me, it's not going to cost much time. Okay, so that was your C part. So the entire question number 7 is done. Now we are going to proceed ahead with the next question, which is question number 8. Now, students, question number 8 is fairly simple question. It's just polynomial division, and we have been doing polynomial division since ages, right? So it's a question for 3 marks. You can see, find the quotient and the remainder when 8x cubed plus 4x squared plus 2x plus 7 is divided by 4x squared plus 1, right? So you can observe that the equation, the expression that you need to divide is a cubic expression, right? It's a cubic expression, and you want to divide it by a quadratic expression. So a power 3 expression needs to be divided by a power 2 expression. Be very much sure that the answer, the quotient, is going to be a linear expression, right, students? Because if you multiply 4x square plus 1 with a linear expression, let's say ax plus b, so 4x square multiplies with ax, you get 4ax cube, which is 8x cube, the very first term of your expression. So be rest assured that your answer is going to be a linear expression. So who is the dividend over here? Who is getting divided? 8x cube plus 4x squared plus 2x plus 7 is getting divided. Who is dividing? Who's a divisor? Who's dividing? 4x squared plus 1 is a divisor. He is dividing the given expression, right? So I am simply going to start my polynomial division. So 4x squared plus 1 is my divisor, and my dividend is 8x cube plus 4x squared plus 2x plus 7. So now you tell me, what's the first term? Now always keep in mind that whenever you're going to perform polynomial division, you always write both of your expressions, the divisor and the dividend. Both of them need to be written in a descending power of the variable. The variable here is x, so you want to write in the descending power of x. Very important, students. Okay, so the first term is 8x cube. Here the first term is 4x squared. So you simply divide 8x cube by 4x squared, and your answer is going to be what? It's going to be 2x. So just write 2x over here. Now you multiply 2x with the divisor. So 4x squared plus 1 multiplies with 2x, you get 8x cube and then plus 2x. So I have written 2x below 2x. Okay, why have we written like this? Because like terms need to be collected together. So 2x is written below the 2x. Even if it was not 2x, I would have still written it below 2x because it's a term of x power 1. Okay, now you are going to subtract, so sign change is going to happen, right? Sign change is going to happen. So obviously you can understand that the 8x cube and minus 8x cube will get cancelled, and then plus 2x and minus 2x is going to get cancelled. So what do you get? You get 4x square and plus 7. So whatever answer is left now, 4x square plus 7, this answer has power which is equal to 4x square plus 1, right? So you are still going to proceed with division. You should stop dividing when the power in the answer is less than the power of the divisor. Students, remember this, okay? You will keep on continuing the division till the power is same for the divisor and the remainder. As soon as the power of the remainder goes below the power of the divisor, you're going to stop division over there. So now you can see there is 4x square, this is 4x square, and you are going to divide this with 4x square, you simply get 1. So I write here plus 1 plus 1. So what's my answer that I'm going to get? So 1 multiplied with 4x square plus 1. So I get 4x square and plus 1. Sign change is going to happen, right, students? Sign change is going to happen. So again, this time 4x square and minus 4x square is going to get cancelled. 7 minus 1 is going to be 6. Now can you see you have got a constant 6. The power, if you observe for the variable, it's x raised to 0, 6 times of x raised to 0, so power is 0, and the power of the divisor is 2, so division is not going to happen. This is where I'm going to stop. So now you can very easily understand that this 2x plus 1 that you have got is your quotient, and the 6 that you have got is your remainder, right, students? So this is what the question was demanding. Find the quotient and the remainder when a particular expression was divided by another expression. Okay, so I am going to write my quotient and the remainder. So quotient is 2x plus 1 and the remainder is 6, right? Now, are you all aware of this one expression that we have learned, which says dividend, the one which is getting divided, is equal to divisor into the quotient plus the remainder, right, students? You're already aware of this, right? Dividend is equal to divisor times quotient plus remainder. One which is getting divided is equal to the divisor multiplied with the quotient plus the remainder. So who is the dividend over here? Who's getting divided? So we know that 8x cube plus 4x square plus 2x plus 7 is getting divided. Who is dividing? 4x square plus 1 is dividing. Who's the quotient that you have got? The quotient is 2x plus 1 and the remainder is 6. So that's your expression in terms of the divisor, the quotient and the remainder. Now why did I write this? Students, take a look at the next question. In the next question, this is a question on integration, right? So hence find the exact value. So hence find the exact value means you want to make use of the answer that has been evaluated in the previous example, right? So hence find the exact value of, so the integral is from 0 to 1 upon 2, the limits are from 0 to 1 upon 2, 0 is the lower limit, 1 upon 2 is the upper limit, and can you see the numerator is 8x cube plus 4x square plus 2x plus 7. That was your dividend, right, students? So we know that this 8x square plus 4x square plus 2x plus 7 was your dividend, and this 4x square plus 1 was your divisor. Now remember, the dividend is in the numerator, the divisor is in the denominator. So if you divide, you're not going to get the answer as 6. 6 was a remainder. You are also not going to get the answer as what it was, I guess 2x plus 1, right? 2x plus 1, that's a quotient. So remember this thing very thoroughly, that division over here is not a complete division. So the answer is not going to be either of the two, 6 or 2x plus 1. The answer should be written something like this. So I'm going to proceed with the solution. I have I is equal to integration 0 to 1 upon 2. The dividend that you have. So can you write the dividend like this? See, 8x cube plus 4x square plus 2x plus 7 is actually this answer, right? So you can use this answer 4x square plus 1 times 2x plus 1 plus 6. If you try and simplify this, you will definitely get the original polynomial. Okay, if you simplify this expression, if you open the brackets, if you simplify, you will get the original expression. So I can write 4x square plus 1 times 2x plus 1, 4x square plus 1 multiplied with 2x plus 1 plus 6 in place of the dividend, and this entire thing is getting divided by 4x square plus 1, and then you have a dx. Now there are two terms in the numerator, this is one term, this is the second term, and there is one term in the denominator. So does it look like a plus b divided by c, which becomes a upon c plus b upon c? A common denominator will get separated with the two numerators. So my next step is going to be 0 to 1 upon 2, 4x square plus 1 multiplies with 2x plus 1 divided by 4x square plus 1, and then plus 6 divided by 4x square plus 1, and you close your bracket and dx. So now I guess you have pretty well understood that the 4x square plus 1 and the 4x square plus 1, this entire term from the first term is going to get cancelled, and you will be only left with 2x plus 1. So I have now integration 0 to 1 upon 2. You have 2x, then a plus 1, then a plus 6 divided by 4x square plus 1 dx, right? So there are three different terms inside your integral. So integration of f of x plus g of x dx is same as integration of f of x dx plus integration of g of x dx. Same is true for the negative sign, but for multiplication division this does not apply. Okay, for when you're using the algebra of integration, only for plus and minus sign the algebra is true. For multiplication division the algebra is not true. So remember this thing very thoroughly. So I have to integrate the first term, which is 2x. So focus on 2x. So there's an integration sign and then you have 2x. Okay, there is an integration sign and then you have 2x. So you are going to just focus on 2x at the beginning. So 2 is a constant, goes outside the integration, x is left, the integration of x is x square upon 2. So I get 2 times of x square upon 2 plus. Now focus on the next term students. So the next term is 1. So what's the integration of 1? So it's like integration of first term plus integration of second term plus integration of third term. That's how it's going to happen. Okay, first term is done, second term, integration of 1. So what's integration of 1 students? Integration of 1 is x, right? You don't have to rely on your formula booklet for all these integrals. You need to remember them. I'm repeatedly telling you to memorize your basic formulas of mathematics. It will pace up your writing skills. It will also develop your what you can say, the analytical part of your brain. Okay, you will be able to guess what steps need to be applied to solve a particular question, how the logic can be built up for a particular question. So learn the formula students, please. So integration of 1 is going to be x, integration of 1 is going to be x, and then the next term that I have, it is integration of 6 upon 4x square plus 1 dx. You want to focus your attention on this. And the limits are from where to where? 0 to 1 upon 2. So I'm going to use the limits at the end. Okay, so I'm going to put the upper limit and the lower limit once I get the entire answer, students. Okay, so I'm going to solve this integral over here, get its answer, and then plug it back into the steps. So integration of 6 upon 4x square plus 1 dx. Students who are very smart need not be doing all this stuff. You can do it directly into the main solution itself. Okay, the main body of the solution. So is 6 a constant which goes outside the integration? 6 is constant, it goes outside integration. Also what I'm doing is, from these two terms that I have, I want to bring the 4 common. Let's bring the 4 common. Even if the second term does not have a 4, you still bring the 4 common. So I take out the 4 common. So you have 1 over. So you have taken out the 4 common, students. You get x square plus 1 upon 4 dx, right? I have taken the 4 common from the denominator. So that's 3 over 2 integration of 1 upon x square plus the next 1 upon 4 is 1 upon 2 square dx. Now some of you might be wondering how these steps are coming into my mind. Students, it's very simple. I know my formula. There is one formula called as 1 upon x square plus a square dx, right? 1 upon x square plus a square dx. Do you know that this integral is 1 upon a tan inverse of x upon a and plus c? Of course, if you're using indefinite integrals, that means if there are no limits, we should write plus c. If there is a limit, then you will not write the plus c. So that's 1 upon a tan inverse of x upon a, isn't it? So I'll be getting my answer as 3 upon 2 into 1 upon a. So that's 1 by 2 tan inverse of x upon a, x upon a. So I have here x upon 1 upon 2. So can you now easily understand that this 2 and the 2 is going to get cancelled, this 2 is going to go up. So my answer is basically 3 times of tan inverse of 2x. So let's take this answer and plug it into this integral. Right, students? So now the main body is going to again continue. So I have also this 2 and 2 is going to get cancelled. So I have x square plus x plus what? Plus 3, right? 3 tan inverse of you have 2x. And the limits are from where to where? The limits are from 0 to 1 upon 2. So I'm going to first of all plug the upper limit 1 upon 2 and then the lower limit 0. So I get 1 upon 2 square plus 1 upon 2 plus 3 tan inverse of 2 times of 1 upon 2. That's your upper limit minus, let's put the lower limit, so that's 0 square plus 0 plus 3 times of tan inverse of 0. Now, don't you all know that tan inverse of 0 is simply going to be 0, or you make use of the calculator. Okay, if you're not aware of the values, make use of the calculator, get your answer. Tan inverse of 0, how much? Tan inverse of 2 and 2 cancels, 2 and 2 cancels, you're going to get 1. What's the value? Okay, make sure now the calculator is kept in the degree mode. Okay, so you get 45 degrees, 0 degree, and so on. Because if you want to get the answer in radian mode, it will give you in decimals. Tan of 45 degrees. Now, are you aware that tan of 45 degrees is 1? Students, tan of 45 degrees is 1. So tan inverse of 1 is 45 degrees and 45 degrees is pi by 4. So you can get your answer in radians as well as in degrees. Okay, so first you get the answer in degrees, and then what is that value in radians is what you need to write. So I know that tan inverse of 1 is going to be pi by 4, so you can write pi by 4 straight away. So I get my answer as, now for this integral, 1 upon 2 square, that's 1 upon 4 plus 1 upon 2 plus 3 times of pi by 4, right? Tan inverse of 1 is pi by 4. And now I want to simplify it further. So 1 upon 4 plus 1 upon 2, that will give me how much? So the second term, you can take LCM as 2 over here. So LCM is 4. So second term needs to be multiplied and divided by 2. So this is going to be 2. So 3 upon 4 plus 3 times of pi by 4. So you can take out 3 by 4 common, and you're left with pi plus 1. If you want, you can still simplify further. You can plug the value of pi as 3.142, or you can use the calculator value of pi. Okay, so the pi is present over here at the bottom. There is pi over here. You want to press the shift key and this key, then you will get the value of pi. So 3 upon 4 times of pi plus 1 is the exact value of the given integral, which was including the question, the expression, the polynomial from the previous question. So that's the B part. It was for 5 marks, students, isn't it? So a pretty simple question for 5 marks. It's time for us to move on ahead with the next question now. Let's understand what the next question is. The next question, students, is based on differential equation. Can you see the question says the variables x and y satisfy the differential equation so and so x plus 1 times 3x plus 1 dy upon dx equal to y, and it is given that y is 1 when x is equal to 1. So this y equal to 1 and x equal to 1 is given to evaluate the constant that is going to come while integrating. Now students, a differential equation is given and you want to find the solution. Okay, differential equation is given, you want to find the solution. Solution are of two different types. One is called as a particular solution, one is called as the general solution. Whenever you are solving a question and no initial conditions are given, in this question the initial conditions are given to us as x equal to 1, y equal to 1. So if the initial conditions are not given, the differential equation will get solved to find the general solution. Okay, you're going to get a general solution. And if the initial conditions are given, so the general solution contains the constant. Okay, and if some initial conditions are given, then you're going to get the particular solution. So these two things you need to remember very properly. So when you have a differential equation and you want to get the solution, then what you need to do, you want to integrate. There is something called as a variable separable form. What does a variable separable form tell us? The variable separable form tells us that the terms of x should be associated with dx. So everything that is in terms of x, you shift it towards the dx, and the terms of y should be associated with dy. So everything that is in y should go towards dy, right? So look at the equation that is given to you. Can you write the equation something like this? It's x plus 1 times 3x plus 1 dy upon dx is equal to y. So that upon dx, I'm just shifting on the other side. In actual, this does not happen. Okay, the dx is not a separate term. Remember that dy upon dx, dy and dx are not two separate terms. It is one entire thing, d by dx of y. D by dx is an operator. It's not like dy is a separate term, dx is a separate term. But then why did I send the dx on the other side? Students, there is lot of things happening in the background. This has already been taught to you in the chapter of differential equations, so we are not going to go in detail at this moment. We just take it for convenience that the dx present in the denominator is simply sent on the other side. Okay, so basically you're going to integrate throughout by x, and that's why the dx vanishes. Okay, so you can now see along with the dy, there are terms of x. These are terms of x. They should be actually with dx, and the term of y should go with dy. So you just want to shuffle the terms, right? All the terms of y should go and associate with dy, and all the terms of x should go and associate with dx. That's it. That simple it is. So I'm going to shift the term of y along with dy. So I get 1 upon y dy is equal to the terms of x will go to dx. So that's 1 over x plus 1 multiplied with 3x plus 1 and dx. Now this is called as the variable separable form. Now can you see all terms of x are with dx and all terms of y are with dy, right? Now next thing that you need to do is to integrate, right? So integrate both the sides. So integration sign. So you can write over here, integrate both sides with respect to x, because x was your independent variable. So you want to integrate with respect to x. Okay, so integrate both sides with respect to x. That's why the dx has gone on the other side. So now if you observe this 1 upon y, 1 over y, the integral, so it is getting integrated with respect to dy. So it's like 1 upon x dx. Integration of 1 upon x is ln of x. So integration of 1 upon y is going to be ln of y, right? So this is going to be ln of y. Now this is very important, students. The second part of the equation that you have in the previous step. Okay, the right hand side of the equation needs to be evaluated. So that's a tricky integration, and that's why this 9 marks has been awarded to this particular question. Okay, so the examiner is expecting you to make use of partial fraction and get the answer. Okay, but then students, you can be smart. Okay, there is not always the need of partial fraction. There sometimes we can use something called as factors in disguise. Okay, so you really need to know your integration very well. Okay, students, learn your integration. So there is something called as a factors in disguise. So I'm going to do some observation over here. I'm going to show that observation to you as well, and then you can also think the same way whenever you're going to solve such kind of questions again. Okay, so in the denominator, so of course there is this method available. So you write a upon x plus 1, you write b upon 3x plus 1, it is equal to 1 upon x plus 1 times 3x plus 1, and every other stuff can be definitely done and you can get your answer. But that's a very lengthy method. I'm not going to follow that method. I'm going to teach you something very cool over here. Okay, so I have this x plus 1 and 3x plus 1. Now observe very carefully. So if you take x plus 1 multiplied with 3 and then you subtract 3x plus 1, what will you get? Take x plus 1 multiplied with 3 and then subtract the 3x plus 1. So it's going to be 3x plus 3 minus 3x minus 1. So plus 3x and minus 3x will get cancelled, and 3 minus 1 is going to be 2. Right, students? Isn't it? It's going to be 2. So what I'm going to do here? Observe. So I write integration of. So you remember now, you want to show this step. Okay, 3 times of x plus 1 minus of 3x plus 1 is equal to 2, right? So you can, if you want, you can simplify it further also. 3x plus 3 minus 3x minus 1. Okay, so that gives you 2. Okay, so in the numerator, you can see a 1. In the numerator, you can see 1. So this 1, I'm going to make it as 2. So I just multiply and divide by 2. That's it. 1 upon 2 outside the integral, 2 inside the integral. And then whole divided by the term that you already had. X plus 1 multiplied with 3x plus 1 and dx. Now you know this 2 in the numerator, this 2 in the numerator, and this 2 are one and the same, and this 2 can be now replaced with this term, isn't it? 2 came from where? It came from 3 times of x plus 1 minus 3x plus 1, right? So you can simply replace the 2 with 3 times of x plus 1 minus 3x plus 1. Now, students, identification of such kind of questions requires tremendous amount of practice. Dedicating yourself towards that practice. Okay, that's very important. So there are few tricky questions. There are few tricks when you are solving integration, and you will come to know those tricks when you actually start solving the topic. So I'm going to replace that 2 in the numerator with the expression that I have written. So I have ln of y is equal to 1 upon 2 integration of the 2 in the numerator is now replaced as 3 times of x plus 1 minus 3x plus 1. This whole divided by, you have x plus 1 multiplied with 3x plus 1 and dx. The common denominator will simply get separated with the 2 numerator, this one and this one. So I'm going to get my term as now 1 upon 2 integration of 3 times of x plus 1 divided by x plus 1 into 3x plus 1 minus, you have 3x plus 1 divided by x plus 1 into 3x plus 1, and then you have dx, right? So you are going to see similar terms in the numerator and the denominator. So there is x plus 1 and x plus 1, that will get cancelled. There is 3x plus 1 and 3x plus 1, that will also get cancelled, right, students? So my next step is going to be 1 upon 2 integration of 3 divided by 3x plus 1 minus 1 divided by x plus 1 and dx. Now what's the integration of 1 upon x, students? It's ln of x. I want you to remember your formulas, right, students?
Make sure that you know your formulas well. So integration of 1 upon x dx is ln of x. Integration of a linear expression, if you have 1 upon ax plus b dx, 1 upon ax plus b dx, the integration is ln of ax plus b over the coefficient of x, which is a. Always remember to divide the entire answer by the coefficient of x if you have a linear expression, students. So these formulas should be well remembered. Okay, so that's your basic formula, and that's the formula for a linear expression, right? So my answer is now going to be 1 upon 2. I'm going to put a nice bracket over here. I'm going to start with a bracket. For the first integral, the 3 is a constant, so I write 3. Then what's the integration of 1 upon 3x plus 1? Integration of 1 upon 3x plus 1 looks like integration of 1 upon ax plus b. So that's ln of 3x plus 1 divided by the coefficient of x. See who is sitting next to x. Next to x, you can see 3. So divide the entire answer by 3. Minus, you have ln of x plus 1. So the number which is sitting next to x, next to this x, is just 1, right? So just immediate number. Okay, x multiplied with what number can you see? It's just 1. So division by 1 is needed, but then division by 1 will make no impact over there. No difference is going to come, right? So, and the most important thing, write a plus c, or better write plus c1 at the beginning, because some more simplification will be carried out and the c1 might change to a new constant. So I can again very well see that the 3 and the 3 will get cancelled. It's ln of 3x plus 1 minus ln of x plus 1. Does it not look like ln of a minus ln of b? And you all know that ln of a minus ln of b is ln of a over b. So I have 1 upon 2 ln of, you get 3x plus 1 divided by x plus 1 and plus c1, or I can write this as ln of 3x plus 1 divided by x plus 1 raised to half plus c1, right? Or I can call it as ln of under root of 3x plus 1 divided by x plus 1 plus c1. Right, students? This is all answer for what? That's the entire thing for ln of ln of y. This is the answer for ln of y. So I'm going to take exponential. Now, have you seen the question? The question says, solve the differential equation, find the exact value of y when x is equal to 3. And it is also given that when y is 1, x is also 1. So this y equal to 1 and x equal to 1 is given to get that value of constant c. Okay, I'm going to get that constant c first. So I'm going to plug the value of y as 1 and x also as 1. Okay, so I'm going to plug the value of y as 1 and x as 1. But before that, what I'm going to do here is I'm going to take exponentials on both the sides. Take exponentials on both the sides. So I write here, take exponentials on both sides. So I get e raised to ln of y, e raised to ln of under root of 3x plus 1 upon x plus 1 plus c1. So is it like e raised to m plus n, right? M is that ln term and then n is that constant term, e raised to m plus n. Is it like e raised to m times e raised to n? So e raised to n is going to be a constant term. I'll write it in the next step. Also, e raised to ln of x. Do you know it is just x, right? All these formulas should be remembered. So e raised to ln of y is going to be y. E raised to ln of root of 3x plus 1 upon x plus 1 plus c1 is going to look like this. E raised to ln of root of 3x plus 1 upon x plus 1 into e raised to c1. But this e raised to c1 can be called as a new constant c. Okay, can be called as a new constant c. You can call it as k also. And again here, e raised to ln of, again some term is there. So you are going to get y is equal to c times of root of 3x plus 1 upon x plus 1. Now, isn't it? It's told to us that when x is 1, y is also 1, or maybe y is 1 when x is 1. So I can say x and y, both of them are 1. So we know x is equal to 1, y is equal to 1. So 1 is equal to c times of root of 3 times of 1 plus 1 divided by 1 plus 1. So that's going to be how much? The value of c is going to be how much? That's 3 times of 1, which is 3. 3 plus 1, that is 4. 4 divided by 2, that comes 2. So that's root 2. So c is going to be 1 over root 2. So what does y come? So y comes, c is 1 upon root 2 multiplied with root of 3x plus 1 divided by x plus 1. So I have got the value of y. Right, students? I've got the value of y. Now what is he asking? Find the exact value of y when x is equal to what? When x is equal to 3. So I'm going to plug the value of x as 3. So let's plug the value of x as 3. And I'm going to find the value of y. So plug x equal to 3. So what does y come? It's 1 over root 2 under root of 3 times of 3 plus 1 whole divided by 3 plus 1. So that's 1 over root 2. So plenty of space is given. So I'm just spacing out my steps. Okay. So that's 3 times 3, which is 9. 9 plus 1, that's 10. 10 divided by 4. 10 divided by 4. So 1 upon root 2 multiplied with root of 10 divided by 4. So that would become 1 upon root 2. And then root of 10 upon 4 is root of 5 upon 2, which is root 5 upon root 2 into root 2, or I get my answer as root 5 upon 2. Okay, if you want, you can get the answer in decimal form also, root 5 upon 2. So it is not a integer, so it's better to get the answer. Root 5 divided by 2. I will get my answer as 1.1180333989. I want to write 3 significant figures, right? So 1.118. So I can write this as 1.12, right? So this is your answer for y. Okay, that's the answer for y. So can you see? Question was for a whooping 9 marks, students. A lot of concepts involved into the question. Of course, the question would have been even more lengthier if you would have used the partial fraction to separate the integral 1 upon x plus 1 times 3x plus 1. It would have taken a lot of time. Okay, so you need to be smart while solving questions. You need to think wisely. You want to think in the future. You want to always think for the next step. Okay, and how do these things can be achieved? It can be achieved only by practice. Okay, so make sure that you are devoting stipulated time to practice, to revise mathematics. So that's how the 9th question is being completed. It's time for us to move to the next question, which is the 10th question. Okay, now the 10th question is from vectors. So we of course need the concept of vectors very thorough over here. So the question starts like this: the points A and B have position vectors 2i plus j plus k and I minus 2j plus 2k. So A and B have position vectors. So that's A bar and B bar, right? So A bar is given to us 2i plus j plus k, and B bar is given to us I minus 2j plus 2k. So I have A bar and B bar. The line L has vector equation so and so. So there is a line L whose vector equation is given to us. So I'll just shade it. Line L has vector equation, this one. Okay. The first question asked is find a vector equation for the line just passing through points A and B. So I want to find the vector equation of a line passing through the points A and B. So do you know that when you write the equation R bar is equal to A bar plus lambda times of B bar. R bar is equal to A bar plus lambda times of B bar. This A bar is a point. It is a point on the line. It is a point on the line, and this B bar is the direction of the line, right? So it can be the line itself, it can be a parallel line, okay, it can be anything. So you need to get IJK form for the line itself or a line which is parallel to the required line, whose equation you are trying to find. So A bar and B bar should be clearly understood. So here A bar and B bar are something different. So this is the direction, right? I want to find the equation of line AB. It is told to us. Find the equation of line which is passing through point A and B. So it's like AB. So AB direction. So direction of AB. Direction of AB bar is going to be B bar minus A bar. You have the value of B bar and A bar. You want to subtract them. Okay. So B bar minus A bar. That's I minus 2J plus 2K minus A bar is 2I plus J plus K. So subtract it very quickly. So that's going to be minus I minus 2J minus J is going to be minus 3J, and plus 2K minus K is going to be plus K, right? So I've got direction of AB bar. You can take any point. There are 2 points lying on the line. One of them is point A and the second one is point B. So you can select either a point A or you can select point B. So I'm going to select point A. So therefore, equation of line AB is going to be R bar is equal to a point on the line. It can be any point. Either you can take point A or you can take the position vector of point B. So a point on the line. So I'll write 2I plus J plus K, right? Plus lambda times of direction of the lines. That's minus I minus 3J plus K. That's what your answer is. That's the equation of line AB. Okay, so the first part is answered. You have fetched 3 marks. Find the acute angle between the directions of AB and L. So I'm first of all going to write the equation of line L. Okay, so I need to go for it. So R is equal to I plus 2J minus 3K. I'll just write the rough equation over here. R is equal to, or R bar is equal to I plus 2J minus 3K. So I can use this. Mu is I minus 3J minus 2K. Okay. So now let's write the equation of line AB and line L. So directions. So this is, I'll first of all write the equation of line AB and L. Equation of AB is R bar is equal to 2y plus j plus k plus lambda times of minus I minus 3j plus k. Therefore, what's the direction of line AB? Students, the direction of line AB is going to be minus I minus 3j plus k. What's the equation of line L? Very quickly, let's write the equation of line L also. So what's the equation of line L given to you? It's R bar is equal to I plus 2j minus 3k. That's a point on the line, right students? That's a point on the line. Plus mu times of I minus 3j minus of 2k. So the term which is multiplied with mu, the vector which is multiplied with mu, is the direction of L. So I can write therefore direction of line L is going to be I minus 3j minus 2k. So I would get the acute angle between the two lines. Students, do you know, if there are 2 lines like this, one of them is A bar, one of them is B bar, and theta is the angle between them, then cos theta is given by A bar dot B bar upon mod of A bar and mod of B bar. That's how we get the acute angle between 2 lines or the directions. Okay, so here, if theta is the angle between line AB and line L, so I can write cos theta is equal to, so A bar dot B bar. So this is A bar, this is B bar. So you want to multiply the coefficients of I, the coefficient of J, and the coefficient of K. So it's going to be minus 1 multiplied with 1. So in the first direction of AB, the coefficient of I is minus 1, right? So minus 1 into 1, and then plus minus 3 times minus 3, right? So the coefficients of j, it's minus 3 and minus 3, and then plus the coefficient of k, it's 1 and minus 2. This entire thing needs to also get divided by under root of, so the coefficients of I, j and k, the whole square. So that's minus 1 square plus minus 3 square. Students, I'm pretty confident that all these concepts are well aware to you, right? If not, please revise. Revise the concept of vectors. So it's 1 square minus 3 square, and of course, if you have any doubts regarding any of the concepts, you know how to reach me, isn't it? You want to go to the comment section, you want to place your doubt, and trust me, I'll make every effort to respond to that query. So I have what? And of course, this entire answer needs to come within the modulus sign because the angle is going to be acute. So this theta should come acute angle. The answer of cos theta should come positive. So it's going to be minus 1 plus 9 and minus 2 divided by, I get root of, so that's 1 plus 9 plus 1. So that's root of 11 multiplied with root of, so that's 1 plus 9, which is 10 plus 2 square, that's 14. So squares of negative numbers is simply going to be positive. So it's going to be 9 minus 3, right? 9 minus 3, that's 6. So 6 divided by root of 11 into root of 14. So I'm going to get theta as cos inverse of 6 over root of 11 into root of 14. So let's quickly get this answer. Okay, so I want the answer in degrees. See, the question demands the answer in what? Giving your answer in degrees. So I definitely need to keep my calculator in degree mode. Okay, and I'm going to now make use of cos inverse. So press the shift sign, the cos key, you'll get cos inverse 6 divided by square root of 11 into 14. So square root of 11 multiplied with square root of 14 is like root of 11 into 14. Come outside the bracket, close it. The answer is 61.086. You remember the instructions, right, which were given on the first page. The instructions clearly say that whenever you are going to find an angle, then it should be to one decimal place. So 61.086 can be written as 61.1 degrees. So this is 61.1 degree. That's my answer, students. Isn't it? This is your answer. You got it? So that completes your part B as well. Now it's time for us to go to part C. Okay. Now you want to show that the line A and B does not intersect. The line which is passing through the points A and B, that means the line AB, does not intersect the line L. You want to show this. Okay. So the procedure for this is going to be, what you do is, let's assume that the lines are going to intersect. Let's assume that lines are going to intersect. So line AB and line L are going to intersect. Now, when there are two lines which are lying in space, remember this, if two lines are there which are lying in space, it is not needed that if the lines are not intersecting, then they are parallel. Of course not. There is some concept called as skew lines. You have learned this concept, right? Concept of skew lines. So one line goes like this, one line goes like this, isn't it? They are not intersecting, they are not parallel, isn't it? So this is what we want to prove over here. So what's the procedure? So I'm going to assume that the lines are going to intersect. Now, if the lines are going to intersect, then there must be one point common, isn't it? That point is the point of intersection. If the lines are going to intersect, then there should be one point in common. That point is called as a point of intersection. Now, when you write R bar is equal to A bar plus lambda times of B bar, this is a point, known point. You know the coordinates of this point. That's a known point on the line. This is the direction of the line. This is the direction of the line. B bar is the direction of the line. What's R bar? What's R bar? So R bar is a running point on the line. So line is very big. There is a point A. Direction is B bar, right? But there are still lot many points on this line, and every single point will have a different coordinate, right? So those coordinates are taken as x, y, z, which is represented by R bar. So R bar is a running point. R bar is called as a running point on the line. Okay, so its coordinates are taken as x, y, z. So now when you have the equation of line L and the equation of line AB, so I have vector equations. Okay, So equation of line AB and L is already written over here. So I'm going to rewrite the equations. So equation of line AB. So that's R bar is equal to, I had 2y plus j plus k, 2y plus j plus k plus lambda times of minus I minus 3j plus k, lambda times of minus I minus 3j plus k. So what I'm going to do here is I'm going to write that R bar as xi plus yj plus zk. So I just modify this equation as x, y, z. That's also a vector equation. 2, 1, 1. That's ijk plus lambda times of minus 1, minus 3 and 1. Right, students? Isn't it? So the top value is of I, the next value is of j, the next value is of k. So that's the equation of line AB. Then equation of line L. That's R bar is equal to what? Equation of line R bar is equal to I plus 2j minus 3k. I plus 2j minus 3k plus mu times of what do you have? I minus 3j minus 2k. I minus 3j minus 2k, right? So I know that R bar is again x, y and z because I'm assuming that the line AB and the line L are intersecting at a point. So this point will have, let's say, coordinates x, y, z. Since it lies on line AB, it should satisfy the equation of line AB. Since the point lies on the line L, it should satisfy the equation of line L. So from both the places, from both the equations of line L, the coordinates of this point of intersection should exactly come same, right? So I'm going to get those coordinates. So that's the reason I've taken R bar as x, y and z in both of my equations. So here it is 1, 2 and minus 3 plus mu times of 1, minus 3 and minus 2. So from the first equation, I'm going to get the value of x as what? So I'm going to compare. So x is going to be 2 plus lambda into minus 1. That's 2 minus lambda. Y is going to be 1 minus 3 lambda. Z is going to be 1 plus lambda. So this is equation number 1, equation 2, equation 3. Okay, so I have these three equations, very important ones. Let's quickly shade them. So that's equation 1, equation 2, equation 3. Similarly, from the second equation, that's equation of line L, x is going to be how much? 1 plus mu. Y is going to be 2 minus 3 mu. Z is going to be minus 3 minus 2 mu. So that's equation 4, 5 and 6. So now you can easily understand that these equations are giving you the values of what? X, Y, Z. So start imagine. One line AB, one line L. They are both intersecting. There is a point of intersection. Point of intersection will have coordinates X, Y, Z. The coordinates of the point of intersection from the line AB, from the line L should not be different. They should be same, right? So equating 1, 2, 3 with 4, 5, 6 respectively, you are going to get the values of x, y and z. So you are going to eliminate x, y, z first, get the value of lambda and mu. So this is what the process is, students. Okay, so equating 1, 2, 3 with 4, 5 and 6 respectively. So I get 2 minus lambda is equal to 1 plus mu. That implies send lambda on one side, so that's lambda plus mu, send the 1 on the other side. So lambda plus mu is equal to 1. Let's call this as equation number 1. From the second one, we are going to compare the values of y now. 1 minus 3 lambda is going to be 2 minus 3 mu. So that implies what? You'll get 3 lambda minus 3 mu is equal to, so 3 lambda has been transferred on the other side and 2 will come on the left side, so that's minus 1. We'll call this as equation 2. And the third equation, 1 plus lambda is going to be minus 3 minus 2 mu. So that implies lambda plus 2 mu is equal to minus 4. That's going to be your third equation. Now what's the process for the, so have you understood what has happened? You had two lines, you took a point of intersection, you said that the lines are intersecting. So to the point of intersection, you said that this point is lying on the first line, it is lying on the second line, so you get the coordinates x, y, z, the coordinates must be same, you equate it, you get equations of lambda and mu. There are three equations of lambda and mu now. These three equations, I will not solve them simultaneously. Out of the three equations, I pick any two equations. It can be 1, 2, it can be 2, 3, it can be 1, 3. So 1 and 2, or 2 and 3, or 3 and 1. Okay, so there can be three different set of values. You definitely are not going to find all the three set of values, students. Just take any one of the pairs, okay, either 1, 2 equation or 2, 3 equations or 1, 3 equation. Solve them simultaneously. Okay, take one pair, solve it simultaneously, get the value of lambda and mu, and this value of lambda and mu you substitute in your third equation, whichever the equation is left. The left out equation you substitute it there. If the equation gets satisfied by the values of lambda and mu that you have evaluated by solving the previous two equations, you will say that the lines are definitely intersecting. The equations, the three equations of lambda and mu are consistent. There exists one value of lambda and mu where all the three equations are getting satisfied. And if all the three equations are getting satisfied, then the lines are definitely intersecting. Remember this process. And of course, if once you get the values of lambda and mu, you have substituted these values in the third equation did not get satisfied, you will say the lines are not intersecting, the equations are not consistent, equation 1, 2 and 3 are not consistent. So I'm going to solve maybe first and the third pair. That's more easier, I can see. Okay, of course you can take any pair that you want. I'm taking first and third, so solving 1 and 3 simultaneously. Solving 1 and 3 simultaneously. Again, I am telling you people, it will not matter if you take any other pair. You can take 1, 2, 2, 3 or 3, 1. Solving 1 and 3 simultaneously. So I have lambda plus 2 mu equal to minus 4, lambda plus mu equal to 1. You are going to subtract, okay, change the signs of all the terms. So that's minus, minus and minus. So lambda and lambda cancels, 2 mu minus mu is going to be mu, minus 4 and minus 1 is going to be minus 5. So I've got a value of mu as minus 5. Mu is minus 5. Substitute this value of mu as minus 5 in any one of the two equations, 1 or 3, okay, not in the second equation, 1 and 3. So you are solving 1 and 3 simultaneously. So substitute mu equal to minus 5 in equation 1. Substitute in equation 1. Substitute, okay, in equation 1. So I get lambda plus mu is minus of 5 is equal to 1. So minus 5 goes on the other side. You get lambda is equal to 1 plus 5, which is 6. So lambda has come 6. So therefore, mu is, or I'll first write the value of lambda. So therefore, I can say lambda is 6 and mu is minus 5. So take these values and you substitute in the second equation. See whether the second equation is getting satisfied or not. So substitute lambda equal to 6 and mu equal to minus 5 in equation 2. In equation 2. So I get 3 times of lambda is 6 minus 3 times of mu is minus 5. That's my LHS, right? So that's 18 plus 15, which is what? 33, which is definitely not equal to minus 1. Am I right? 3 times of lambda is 6, that's 18 minus 3 minus 5, that's plus 15, so that gave me 33, which is not equal to minus 1, isn't it? So that is not equal to RHS. That means what did you conclude from here? The values of lambda and mu are not satisfying the third equation. That means the lines are definitely not intersecting. So I can say therefore lines are not intersecting. That's it, students, isn't it? So you can see the question looks pretty lengthy, but if you know your concepts well, then you will definitely manage to solve the question. Multiple questions are coming from this topic. Okay, so many question papers you can observe will be having this question on vectors. Is that our last question, students? Have we reached to the end? Yes. So finally, we are going towards our last question. Too lengthy paper, right? Okay, but we should be showing patience while solving all the questions, isn't it? So uh, we have to be very patient over here while solving pure math 3, because there are so many very important topics and we want to score well. We want to score the perfect A star, isn't it? Now, I'm going to go to my last question. The diagram shows the curve y is equal to sin x times cos 2x for x lying between 0 to pi by 2. It's half of pi, that means it's pi by 2. And you can observe that x can take value 0 and pi by 2, both the values. And its maximum point M. So the diagram is showing the curve y equal to sin x times cos 2x lying from 0 to pi by 2, and it also shows the maximum point M. Find the x coordinate of point M. Point M is your maximum point, and you should be giving your answer correct to 3 significant figures. See, you want to write 3 significant figures. Even if you have not observed this in the question, even if it was not mentioned in the question, still we would have taken 3 significant figures, because our instructions were given at the very start of the question paper that you should be writing 3 significant figures for the answers which are not integers. So I want to find the x coordinate of point M. Who is point M? So let's ask that question to yourself first of all. Who is point M? Is point M not the highest point of the curve? Isn't it? It's a maximum point of the curve. So wherever the curve exhibits maximum or minimum value, isn't it? The curve can go to a highest point or it might go to a lowest point. So wherever, at whichever point the curve attains the maximum value, at that particular point, the first order derivative is equal to 0. Don't you remember this? Right? The first order derivative becomes equal to 0 for the point where the function might be having a maximum or the minimum value. If the second order derivative is obtained and if it is greater than 0, then the function has a minimum value. If the second order derivative is obtained and it is less than 0, that is negative, then the function has a maximum value. But for maximum or minimum value, in both of the cases, the first order derivative is definitely equal to what? Is equal to 0. So if you want to find the coordinates of point M, what you need to do, you know that point M is the maximum point. So the derivative of the function for that point M is going to be equal to what? It's going to be equal to 0. So I have y is equal to what? Y equal to sin x times cos 2x. Y is equal to sin x into cos 2x. For M to be maximum, dy upon dx at point M must be equal to 0. So you want to just equate derivative with 0, right? Dy upon dx must become equal to 0. So I'm going to differentiate both sides with respect to x. So I get dy upon dx is equal to d upon dx of sin x into cos 2x. I'm going to make use of the u into v rule. What does the u into v rule say? V as it is, derivative of u. So cos 2x as it is. Cos 2x as it is. Derivative of sin x. Derivative of sin x is cos x plus sin x as it is. Derivative of cos 2x. So derivative of cos is minus sin, and it is not cos x. It is cos 2x, composite function. So again derivative of 2x needs to be taken. So the derivative of cos 2x is minus sin 2x. Again the derivative of 2x is 2, right? So the derivative dy upon dx has come what? Cos 2x into cos x minus 2 sin 2x into sine x. But I know dy upon dx is equal to what? Is equal to 0, right? So I'll write here, but dy upon dx is equal to 0. So I'll say cos 2x into cos x minus 2 times of sine 2x into sine x should become equal to 0, right? So you want to simplify this trigonometric expression needs to be simplified. You want to solve for the value of x. How do we do that? Okay, so observe the steps. It's very simple. So what I'm going to do here is I'm going to collect cos 2x and cos x on one side, and I'm going to send this term of 2 sine 2x sine x on the other side. So it's a negative term, it goes on the other side, becomes positive. You get 2 times of sine 2x into sine x. See, we have a formula cos A cos B minus sine A sine B. There is no constant attached to sine A into sine B. So you cannot make use of the compound angle formula even though it looks like a compound angle formula. Cos A cos B minus sine A sine B. Okay, but it is not cos A cos B minus sine A sine B. It is cos A cos B minus some number multiplied with sine A sine B. So you are definitely not going to make use of the compound angle formula over here. On the contrary, you should be thinking something else over here. You want to get the value of x, right? So I have transferred the term of 2 sine 2x sine x on the other side, the right hand side. Now I'm going to send this cos 2x and cos x below sine 2x and sine x. So one will be left on the left side. This is 2 sine 2x divided by cos. It's a very good example, students. So pay proper attention. Sine x divided by cos x. So can I say it's like 1 upon 2, it is equal to tan 2x into tan x, right? Still we do not know how to proceed further. Tan 2x into tan x, I don't have any formula. Don't start searching in the formula list whether we have a formula for tan 2x into tan x. No, we don't have, but we have this formula. See, I am now going to evaluate the value of x. I want to get the value of x. So there is one term which is a double angle, tan 2x, and then there is tan x. You can say half angle, right? So double angle, half angle is one and the same thing. So I have this tan 2x, and then I have this tan x. What I'm going to do here is I'm going to transform that tan 2x in terms of tan x. So you can check your formula list. There is a formula available for tan 2x in terms of tan x, but if you know your formula, then you'll be more wiser. So tan 2x, it is 2 tan x divided by 1 minus tan square x. How many of you are knowing this formula? Students, isn't it? Very important formula. Tan 2x is 2 tan x upon 1 minus tan square x. So I get 1 upon 2 is equal to the tan 2x is written as what? 2 tan x divided by 1 minus tan square x, and this needs to be multiplied with tan x. So I get 1 upon 2, I get 2 tan square x divided by 1 minus tan square x. What I'm going to do here is, for some time, I'm going to write the value of tan x as m. Let us say tan x is taken as m for some time. So I get 1 by 2 is equal to 2m upon 1 minus m square. Can you simplify? So I get 1 minus m square is equal to 2 times 2m. So that's 4m. All things are good, right? So you get 1 minus m square is equal to 4m. I hope I have done all the things correct over here, isn't it? So 1 upon 2, you get 2 tan square x. Yeah. So one thing I've missed out, students. One thing I've missed out. Have you noticed that? So here, this is tan square x. So it would be m square. Very important, students. You need to be very attentive while solving questions. So we are on the verge of ending this paper, right? So we need to be very attentive, right? There might be a mental fatigue that might come after solving such a long paper. Okay, so we have to overcome that, and that can be overcome by solving more and more question papers. Okay, so every single day you take a question paper and you try and solve it. You'll find solutions on our channel over here. So that's 4m square. So let's correct both the terms together. So I'm going to get 1 is equal to 5m square, or I can say m square is equal to 1 upon 5. But m is nothing but what? It's tan x. So I'm going to use the space over here. So tan x is equal to, or tan square x is equal to 1 upon 5. Tan x becomes equal to plus and minus 1 upon root 5. Now what is told about x? Is x lying between 0 to pi by 2? That means x is an angle of the first quadrant. If x is an angle of the first quadrant, that's the first quadrant angle, right students? If x is a first quadrant angle, can you not say that tan x should be positive? It cannot be negative. Negative tan x, it is in the second quadrant, but x is lying in the first quadrant. So I can write here, but x lies in first quadrant, right? Therefore, tan x should be taken positive. So that's 1 upon root 5. Are we in the need of x? Yes, students, we are trying to find the x coordinate of point m, that is x. So x is going to be tan inverse of 1 upon root 5. Let's make use of the calculator. Okay, so tan inverse of 1 upon root 5. Make sure that you're going to write your answer in radian mode. Students, you'll be writing your answer in radian mode. Okay, so means you'll be using the calculator in radian mode. You'll be writing your answers, the angle in radians. So no, my calculator is not in radian mode. Let's bring it to the radian mode. Okay, now you press shift and tan, that will give you tan inverse 1 divided by root 5. Isn't that what we are trying to find? Yes, tan inverse of 1 upon root 5. So the answer comes 0.4205. So I can write 0.421. 0.421. So what's the x coordinate of point M? It's 0.421. So therefore I can write x coordinate of point M is 0.421. That's your answer, students, right? And yeah, finally we are on to the last part, the last question of the question paper. Let's quickly wind it up, students. Now the last question says what? Using the substitution u equal to cos x. Using the substitution u equal to cos x, find the area of the shaded region. Find the area of the shaded region that has been enclosed by the curve and the x-axis, isn't it? By the curve and the x-axis and in the first quadrant. Giving your answer in the simplified exact form. So you want to take care of that, okay? Giving your answer in simplified exact form. So this is the shaded region. You can very well see the shaded region. You want to find the area of the shaded region. So now you know what are the coordinates of this point. You know the coordinates of this point, right? What are the coordinates of this point? It's 0, 0. X and y, both of them are 0. What are the coordinates of this point? Over here, y is 0. I don't know what's the x coordinate. I do not know what's the x coordinate. I call it as x1, but I know the y coordinate is 0, right? So I have to get that x coordinate, because if you want to integrate, you will need the limits. If you want to integrate, you will need the limits. Limits are for what? X equal to. So if I want the area under the curve, this area, if I'm trying to find, then I should have the vertical boundaries. The limits will become the vertical boundaries. So I'm going to put vertical boundaries over here. This is one vertical boundary. I hope you are able to see, isn't it? So this is one of the vertical boundary. Okay, so that's a vertical boundary. I'll just thicken my pencil. That's one vertical boundary. Okay, so here you can easily understand that x is going to be 0. And the other vertical boundary is at this particular point. Okay, it is at this particular point. So I am going to shift it a little bit over here. Okay, so you need to know your vertical boundaries. You want to know the x coordinates, students. So let's quickly write. This one is x equal to 0, right? This I don't know. I want to find x1, but I know y is 0. What's the equation of this curve? Y is equal to, the equation of the curve is what? Sin x into cos 2x. Sin x into cos 2x. I think that's not visible. This pen is not visible. This color is not visible. So I'm going to plug the value of y as 0, isn't it? For this point, maybe I can call it as a. This point I can call it as a. So for point A, y coordinate is 0. Is that right? For point A, y coordinate is 0. That means I can say sin x multiplied with cos 2x will become equal to 0. So that means either sin x is 0 or you can say cos 2x is 0. If sin x is 0, x can become what? X can become equal to 0, pi, 2 pi, 3 pi and so on, right? If sin x is 0, students, if sin x is taken as 0, then x will become equal to 0, pi, 2 pi, 3 pi, 4 pi and so on. But I know that x lies between 0 to pi by 2. So therefore I can say x will become equal to 0. X will become equal to 0. Likewise, if cos 2x is taken as 0, if cos 2x is taken as 0, now which angle of cos gives you 0? Cos of what angle? The answer comes 0. Cos of pi by 2. You know that. Cos of pi by 2, cos of 3 pi by 2, cos of 5 pi by 2. So odd multiples of pi by 2. The answer is 0. But I know that the angle has to lie between 0 to pi by 2. So I cannot go for 3 pi by 2 or 5 pi by 2 or 7 pi by 2 and so on. I have to stick with pi by 2. So therefore I can say 2x must be equal to pi by 2, or that gives me x equal to pi by 4. So that's the correct value, right? For point A, x cannot be 0. Can you understand that? Point A, it is ahead of the origin, so it cannot be 0, right? So therefore I can say for this point A, x coordinate is pi by 4. So A has what coordinates? Pi by 4 comma 0. So x is equal to, for this line, x is equal to pi by 4. So that's what your limit is, students. Okay, so very interesting question, right? So we are going to go back, and also using the substitution u equal to cos x. Also, students, you want to use the substitution u equal to cos x. That also you need to take care of. I can solve the question without using the substitution also, but if you do that, you get a 0. Okay, because the question clearly says using the substitution u equal to cos x. So you have to mandatorily make use of the substitution which is given into the question. So the area of the shaded region, is what? It is nothing but the integration, right? Area under the curve, area of the shaded region, area under the curve, area under the curve is integration. So I can write here area of the shaded region. Area of the shaded region is equal to integration x equal to 0 to x equal to pi by 4. And you want to find the area under what curve? The equation of the curve is what? Is it sin x times cos 2x? It's sin x times cos 2x and dx, right, students? So this is what you want to start with. Okay, you have your integration sin x into cos 2x. You want to integrate that. Okay, you have to make use of the substitution u equal to cos x. You want to make use of the substitution u equal to cos x, and then limits are from 0 to pi by 4. Okay, you'll be getting your answer. So I'm going to make use of the substitution u is equal to cos x. Substitute u equal to cos x. So if u is cos x, you differentiate both the sides with respect to x. Du upon dx becomes equal to minus sin x, or I say du is equal to minus sin x dx, right? So sin x into dx becomes minus du. Therefore, sin x into dx becomes equal to minus du. So this sin x and this dx, sin x and dx, they are both going to become minus du. Also, I want to change every cos x. Students, every cos x needs to be changed. Now, your question does not contain cos x. It contains cos 2x. use your formulas, students formulas. Do you know that cos 2x is 2 cos square x minus 1, right? You should be knowing this formula. Cos 2x is 2 cos square x minus 1. Why using this formula? Because you want to use the substitution of cos x. Cos x is taken as u. So you want to bring that cos 2x in terms of cos x, right? And the limits x equal to 0 and x equal to pi by 4 also needs to be changed. So whenever you're using substitution, three things students must be remembered. Three things. The first thing is every x must change from the integral. Every single x, wherever the x is present, it has to change. Okay. Then the dx has to change, and then the limits have to change. Okay. All the x's will change, the dx will change, and the limits are going to change. Okay. So I have replacement for all the x's. So cos x is going to be u. I have the replacement for the dx. Okay, so sin x dx is going to be minus u. I now need to change my limits as well. Okay, let's change the limits. So when x is 0, what do I get? When x is 0, I have u as cos of x. So cos of 0, which is going to be 1, right? And then when x is, what's the upper limit? It's going to be pi by 4, right? It's going to be pi by 4. So when x is pi by 4, u is going to be cos of pi by 4. So you all know that cos of 45 degrees, pi by 4 is 45 degrees. It's 1 upon root 2, right? U is 1 upon root 2. So my limits are going to be what? So I write area of the shaded region. Area of the shaded region is equal to integration of. So x equal to 0 to x equal to pi by 4, it becomes u equal to 1. So when x is 0, u is going to be equal to 1. So u is equal to 1 upon root 2, right? Also, this cos 2x, you are going to write 2 cos square x minus 1. And this sin x and dx are going to become minus 2. So I have 2 u square minus 1 and minus d. So bring the negative sign out, take out the negative sign. So integration 1 to 1 upon root 2, you are left with 2u square minus 1 d. Standard integration, students, right? So the integration of x square, if you remember, is x cube over 3. So integration of u square, be careful with the negative sign. So minus, put up a nice big bracket, then 2 is a constant, u square's integration is u cube upon 3, minus 1's integration is u, limits are from 1 to 1 upon root 2, right? So you are now going to plug all the values. So that's minus of 2 by 3 into u cube. So I'll write 1 upon root 2 the whole cube, minus u is 1 upon root 2. That's the answer for the upper limit, right? I'm going to put a very big bracket also. Okay, so that's the answer for the upper limit. Now we want to write the answer for what? The lower limit as well. Okay, so this was the answer for the upper limit minus lower limit. U is 1, so that's 2 times of 1 cube upon 3 minus of 1. Close the bracket, and a big bracket is also going to get closed. We had a negative sign outside the big bracket. Okay, I'm going to solve it now. So you can make use of the calculator and simply get the answer. So it's 2 upon 3 multiplies with 1 upon root 2 cube. So I have 1 divided by root 2. I get some value. I'm going to take the cube of that value. Okay, I got some value. It is going to multiply with 2 by 3. Okay, I'll get some value. I'm going to then subtract 1 upon root 2. I get some value. Again, I'm going to subtract 2 upon 3 minus 1, because 1 cube is going to be 1, right? So calculations need to be done very carefully. So it's 1 minus root 2 over 3. There is a negative sign outside, so the answer is going to be root 2 minus 1 divided by 3. Your answer needs to be specified in the simplified exact form. So that's what the answer is. Root 2 minus 1 divided by 3. If you want to get it in decimal, it's 0.138 significant figures, three number of significant figures, 0.138. That's what the answer is for your last question. Did you see the additional page is not required? So students, let me go ahead and stop sharing that screen. So students, that's the end of the question paper that we have taken in this session. Students, I'm really confident that whatever things I've explained you through this video are well understood by you. But in case if there is any doubts, any queries, any concepts that you need to revise, you need to ask, you know where to go. Please go to the comment section, put up your doubt, your query, or any other thing that you need to know, and I'll make every effort to respond back to that query. Students, it's time for me to say a goodbye. The things that I've taken here, please make sure that you keep revising it, keep revisiting this video. And the most important thing, students, if this video has brought any change in your life, if you have understood the concepts, if you have gained knowledge through this video, please go ahead, like this video, share it with your friends, and please do subscribe to my channel. Your subscriptions motivates me to keep on making more and more such videos. So students, by the time we meet again, that's a goodbye from my side. You please take good care of yourself, keep learning, keep growing. Bye bye.